In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and dignity.
Also, let us know from which schools you are connecting to us from. Mr. Kota will be dealing with Maths Paper 2 during the course of today. We are hosting the session live from South Peninsula High School here in Cape Town. Please do us a favor, everyone at home that's logged in. We are 30 subscribers short of 7,000. So if you can hit that subscribe button, Mr. Kota, we need that nudge. So the intention for this session today is to prepare our grade 12 learners for very important maths examination. Um, and to everyone connected online, feel free to pose your questions, give us your feedback. The code that we had was a very good one. Please kindly be advised that these videos, you can refer back to this videos. I'm going to be calling on Mr. Adnan Idris. He's one of the educators here at South Peninsula High School. And this center has been a partner to this project it's the second year running now. This project is jointly hosted with the Department of Basic Education, the Thread Awqaf iSkills, and Mr. Adnan will share a few words with us. Adnan.
Thank you so much. So students, this is your second day here, and we can't emphasize enough, and this is everyone that is tuned in and has been watching. The thing is, it doesn't matter how well you do in paper one, and generally as markers at all the different centers, we find that you do extremely well at paper one. However, when it comes to paper two, you don't do as well as what you do at paper one. And usually what happens is that you score a very lovely mark for paper one. And because paper two is lower, it kind of drags that mark down. So therefore, paper two, there are basic principles that you kind of always struggle with. And this is the reason that they have these workshops. The sections that they've earmarked where students do very badly at, and I know you already know what they are, it's going to be your trigonometry and your Euclidean, especially the trigonometry. Somehow, some of the kids manage to plow through the Euclidean, but they really, really struggle with trigonometry. The statistics you find okay because it's usually the nice, easy little section. You then get to the first question, analytical, which is your grade 9, and you go, oh, this seems okay. And unfortunately, that is where the okay stops. So now it's grade 12, you see circles, and well, that's when your brain starts going into circles. So this is so important. We cannot stress how important this is. Every single year, all the chief markers in every different province, so we meet them in every different province, they all draw up what is called a moderation report. And what this report consists of is every province, they mark all the scripts of the students in that province, and they highlight all the mistakes that students make in that particular province. What they then do is they take all of these reports, so it's the 9 reports, and they put it together in what they call the national report. The national report means for the whole country. And if I have to ask any one of you and anybody who's online, how many of you have downloaded that national report, we'll probably get very few hands going up. And the reason that we know that is because many teachers don't download those reports either. That report is so important. So please, this afternoon, late afternoon when you're at home, download the reports for paper 2, as well as paper 1, because that will tell you where students went wrong and the advice they give to students in those sections. Because remember, those sections are going to be repeated once again. And students, you can learn so much from their reports. We take painstakingly, we draw up those reports, sometimes they're 25 pages long, And this is per province. And then they put it together in one book where they go through every single question and every single sub question, like they would say in 1.1.2, this is what we found students lacked or didn't know. And why that report is so important is because so that you do not make the mistakes of students before you. So other than that, I hope you're going to have a very lovely afternoon. I know maths is always going to be a lovely afternoon. And I hope you learn a lot. That's the thing. You've got to learn from these sessions. There are a lot of, there's going to be things that you didn't know. There's going to be things of a new approach. Take all of that in, and post these sessions, please go home and go and practice what you've learned. It's no use sitting here passively, just taking in everything, and after this afternoon, you go, well, now I'm ready. No, now you've got to test yourself. Okay, you've learned a lot, but you want to know what you've learned, can you actually put into practice? And that is extremely important. So good luck to all of you. I hope you have a lovely afternoon this afternoon as you had yesterday, and everything of the best to all of you for the exam. Shukran.
We say thank you to Adnan for that comprehensive way of introduction and opening remarks. So yes, mathematics is required for all futures, careers of the future. So you need maths if you want to attain a good kind of career option in terms of studies, and also in terms of work out there. Whether you want to be an accountant, a fashion buyer, IT expert, analyst, actuary like Rory-san, the list goes on. Maths is required. So these workshops are here to assist you. So that's enough speaking from my side. Mr. Kouter, the maths facilitator, the main brain, the maths machine, the man, the myth, and the legend. He'll be taking you, it's a loaded gun today.
Yeah, it's a loaded gun.
So he'll be taking you through the session today. Please engage with him online and in person. Mr. Kouter has been the implementing agent and the facilitator for this maths intervention that Awqaf has been hosting since 2015. We've gone to the length and the breadth of South Africa, and we are here today. Make full use and take full advantage that Mr. Kouter is here. So to bring on Mr. Kouter, we're going to ask Khalid to cue the maths rocket. We're all going to board onto the maths rocket. And so Khalid, if you can cue that video, and then we'll get Mr. Kouter on the show so we can get started with maths paper 2. Cue the video, Khalid.
Eight, seven, six, five, 3,
Okay. Let's see. Here we go. Testing 1, 2. Are we live? We good? Let's just wait for some of those students to settle down there at the back. Good morning, good morning, good morning. Saubona, Dumela. Assalamu alaikum. Goeiemorgen. Welcome, SA. Welcome to all our 7,000 learners. I think we've passed the 7,000 mark already. So just to say thank you all. I'm glad that you guys enjoyed. We got some fantastic feedback from yesterday's sessions. So Jazakallah, and thank you so much. Now, yes, we have put on, yesterday we put up for paper 2 today that we're going to be starting immediately with paper 2. But what we're going to do, let's start off with Finance. We didn't do the finance component yesterday. So before we go into the paper 2, let's start off with the finance. And immediately after that, we kick into paper 2. Are we good? All right. You guys can hear me? Is that better? Okay. Getting all the attention here. Right. We've got a full screen here. We've got a full screen. Let's get started, guys. Welcome, welcome, welcome. All the learners coming in online. Chivasi High School. Yes, we're going to have breaks in between. If you were part of yesterday's program, you know, we're going to push from now till 10:30. Our first break will be from 10:30 to 11 o'clock. We'll push through again till 12:30. We'll push, you'll have a break until 1:15. And yeah, and that would be it's broken up into 3 sessions. So relax, we will be getting breaks. We'll be pushing for an hour, about an hour and a half at a time. And immediately after that, you'll go for a 30-minute break. So guys, let's get started. Good morning, good morning, good morning. Skibidi toilet, you know. All right, let's go. Let's get started. Okay, we're starting with finance, guys. So put the heading there, finance. We're starting with finance. Let's go through what you need to know for finance. Here's your overview for finance, right? Finance, you need to know depreciation according to the reducing balance method, right? This is from grade 11. This is from grade 11. You also need to know converting nominal to effective interest rates. So this is grade 11 work. So make a note of this. We're going to go through each of this. I'm going to go through examples of each. Converting nominal to effective interest rates. There we go. Take this all down. So that's your grade 11. Let's start with grade 12. Let's start with grade 12. The first thing we need to know is future value and present value annuities. Now, annuities are monthly repayments. Monthly repayments into a fund. Right. The second concept we need to know is the balance outstanding on a loan. Very important. 100% you're going to be tested on this. The balance outstanding. Then you need to know the trade-in of an asset. You need to know the trade-in model. Then you need to know the immediate payment. When you make a payment immediately, and how does that affect your monthly repayment? Then we have what we call the deferred payment, where you pay late. And then we have what we call the final payment. So these are the concepts that you need to know. Once you know this, you can apply these concepts to no matter what question they ask you for 20 marks. Remember, finance is about 20 marks. So we went through the program, the map. Remember, we mapped it out yesterday. We said, right, we're going to get full marks in functions, full marks in calculus, full marks in algebra, full marks in finance. You still got sequences and series and probability, full marks. I mean, you're looking at about 80 to 90% guaranteed already for paper 1. So we've got 1, 2, 3, 4, 5, 6, 7. So we're going to do 7 examples. Then I'm going to take out one from a past paper where you take out a loan, you stop paying, and you know what they're doing? They're asking you a new concept. And I've picked this up this year only. I've picked up a new concept, like Mr. Idris was speaking about. I was going through that document, and what they want the learners to also start focusing on right now is missing payments. So let's add that to our list. This wasn't added to our list before. This wasn't. So if you attended our previous workshop, this concept wasn't put in. I've introduced this concept to add into our mind map. So I'm just going to make another arrow here, and we call that the missing payment model. And I've got a very strong hunch this is also going to be one of your questions in your prelims or in your finals this year. Let's pray my hunches are right. So there we go, guys. Yes, we will do it. We will do probability. I want to finish this. We're going to paper 2 and we'll end up with probability today. Okay? So let's get started. Let's get cracking. Welcome, welcome, welcome. An official welcome. I see people still joining the session. People got up late this morning. Sunday morning, still bubble-ass from last night. Here we go, here we go, here we go. Let's go. Right. So these are our concepts. We're going to be doing one example of each. If you pay attention, I promise you, you will score full marks. Full. You'll total this topic in your exam. I'll show you when to use future value, when to use present value, how to use it, and the mechanics behind it. So it's very important that you stay focused, you stay logged on. Let's start on with the depreciation model, which is a very general model. They love this question, asking about depreciation. I'm clearing the frame. Let's get started. Here we go. Your first question on depreciation. If you have been part of our previous workshops, let's say, how long will it take? Take this one down. How long will it take for equipment to depreciate to 75% of its original value based on the reducing balance method? On reducing balance method. What's another word for reducing balance? No. Yes, it is compound decrease, but what's another word for reducing? Come on, those of you who do accounting. Diminishing balance. Another word for reducing balance is diminishing balance method. At, let's say 14% per annum. It's a 5-mark question. 3 to 5 marks. Now today, it's as if we are writing a mock prelim or as if we are writing a mock final exam. So if we all work through it together, you'll get the concept. And remember, this is not the end all. Like Mr. Idris said, the purpose is after this, you master all these models that we've done yesterday and today. If you missed yesterday's session, you go back to the Awqaf website on YouTube and just go back to yesterday. Master all the concepts we've done yesterday. Master everything we're going to be doing today. And then start with your whole file of past papers. And then you start applying whatever you have mastered. Okay, let's go. In our answer, reducing balance method, A equals P. 1 minus I to the power n. Right. If your original amount is P, 1 minus your depreciation rate, 0.14, convert it to a decimal. Some of you put it as, some of your teachers or at school put it as 14 over 100. 14 over 100, sometimes your memos will show you 14 over 100 is 0.14. I like converting it to a decimal from the beginning. To the power n, how long? Whenever they say how long, we are looking for time, and time is n. Now, if your original amount is P, they say to 75% of its original amount. So, the A value, the book value, the scrap value would be 0.75p. Yes or no? 75% of its original. Again, sometimes your memo will give you this as X. And they'll say 0.75X. No problem, it's exactly the same thing. If it was 50% of it, it would be 0.5p. That would be your book value. If it was 25%, 0.25p. Right. Now we divide by P. We divide by P. I'm left with 0.75 is equal to 1 minus 0.14 is 0.86 to the power n. We are looking for n. So what system in mathematics do we use? Logs, of course. Right. So here goes. Attach a log, attach a log. What you do on the left, you do on the right. So you're going to have log 0,75 is equal to log 0,86 to the power n. Yes or no? Are you guys following? Onliners, are we okay? Yes, we're finishing this. And then we're finishing the finance, and then we are going into paper 2. Right, let's go. 1 minus 0,14 is 0,86 to the power n. Right, what's the first thing we do after attaching the log? The n drops and becomes the base. So now you have n log 0,86 is equal to log 0,75. N will equal to, we want to isolate n, so it would be log 0,75 divided by log 0,86. And this will give you your number of years. So log 0,75 close brackets divided by log 0,86 close brackets equals, I get 1,9. 1,9. 1,907 or 1,9 years. There we go. Right? Onliners, are we okay? Are we good? Yes, Zakira, today is paper 2. I'm finishing the finance from yesterday. We are completing the finance from yesterday, and then we'll be going into paper 2. That's to answer Zakira. Okay, so here we go. That was your depreciation model, right? Depreciation where you are solving for n. Let's do one where we need to convert nominal to effective rates. But now not just your grade 11 one. Nominal monthly to effective quarterly. Right, that's grade 12. Okay, so let's go. Let's go. So you've taken this one down. Let's go. Let's do another one. Right. Convert 8.3% per annum compounded monthly to an effective interest rate compounded quarterly. There we go. And that would be for 4 marks. Question, answer. Convert 8.3% per annum compounded monthly. So now the important component compounded monthly to an effective interest rate compounded quarterly. Masia asked, can we skip the last 2 steps when in the previous one? Yeah, you can do it one shot on your calculator if you got log of a number to a base, and then you can just punch it into your calculator. Yes, you can. As long as you get no, don't round it off to 2 years. 1,9 years, leave it, because 0.9 of a year is a year, and 0.9 out of 12, which is probably about, 0.9 times 12. It's 1 year, 11 months. So it's not actually exactly 2 years. So don't round it off to 2 years, that previous one. Leave it as 1,9, because it was 907 if I'm not mistaken. So leave it as 1,9. Don't change it. Don't round it off to 2. If you wanted to, you can put the approximate sign. Do you guys know the approximate sign? The approximate sign is it's a wavy equal to sign. Approximately 2 years. Okay, let's do this one here. Let's do this one here, guys. So 1 plus I effective compounded quarterly is equal to 1 plus I nominal over its compoundings, right? I nominal, your nominal amount. So this is going to be 0,083 over 12 compounded monthly to the power 12. Right, now make I effective the subject of your formula. Please, guys, no rounding off right through until your final answer. So, if this was square, to get rid of the square, we'd find the square root. If this was cube, I'd find the cube root. So, it's to the power 4. So, what root will I find? The fourth root. So, now I'm going to say 1 plus I e over 4 is equal to the fourth root of 1 plus, so let's put this as 1 plus 0,083 over 12 to the power 12. Now, how do I remove the third sign, guys? How do I remove the third sign? Your inside power divided by your outside root. Do you remember that? Right. So 1 plus IE is equal to 1 plus 0,083 over 12 to the power 12 divided by 4, which is 3. Yes? Inside power divided by outside root. Normal algebra. No rocket science. Exponents, thirds. Yeah. Sorry? Oh, over 4. Right? Are you guys with me? Good. Now take the 1 on the other side. So IE over 4 is equal to 1 plus 0,083 over 12 to the power 3. The plus 1 will come on the other side as negative 1. So I want IE. I don't want IE over 4. I want IE on its own. So what's the opposite of division? Yes. So we're going to multiply this side by 4. We're going to multiply the entire side by 4. Please make sure you get your algebra correct. Please make sure you get your algebra correct. Now you go into your calculator. Right at the end. 4, open brackets, 1 plus fraction 0,083 over 12. Close brackets to the power 3 minus 1, close brackets, boom. You get your answer 0,08357. In fact, you can round this on of 8,35, 8,36. You can even say, I would say this is equal to 8, if I multiply it by 100, 8,36. 8,36% per annum, compounded quarterly. Right? Yes? Yes, per annum compounded quarterly. It's a requirement because they tell you your interest rate compounded quarterly. So you must stay per annum compounded quarterly. Right. Your marks will be allocated, obviously, here on the top for correct substitution. And then for manipulation of your formula, 1, 2, 3, and your final answer, 4. 4 marks. Okay. Right. We now go into annuities, guys. We now go into annuities. Future value, present value annuities. Right, we're getting into that. I see people are jumping the gun there, sir. Do we use future value or present value when you withdraw from an investment? I'll explain all that to you. This was still the grade 11 component. We're now getting into annuities. Let's get into annuities. Now, many of you, again, to answer the question that Aluluto has just asked, many of you get confused. You don't know when to use the future value and when to use the present value formula. Right. I want you to remember this. Future value let's put our formulas down. It's x into 1 plus I to the power n minus 1 all over I, and present value is equal to x into 1 minus 1 plus I to the minus n all over I, where n represents your number of payments, not your number of years. Very important. N represents your number of payments, not your number of years. X, obviously, we all know by now, represents what? Monthly repayment. Very good. Okay, now pay attention. We use future value whenever we have a savings account, or another word for savings account is what we call a sinking fund. We use the present value formula whenever we are dealing with loans, whenever you borrow money from the bank. When you are repaying a car, you buy a car, you finance it through the bank, you buy a house over 30 years, you're taking out a loan. Whenever you're taking out a loan, present value. Whenever you are savings or sinking fund, future value. So you guys can just remember it like this. FSPL, flippant stupid people. Future value for savings, present value for loans. Right, here's a little acronym for you. So if you don't know, the minute you start with finance, just put FSPL on the top. Right, flippant stupid people. Future value, that will help you to remember that when the question is talking about, and you'll see, by utilizing this little acronym, FSPL, yeah, you will fly through finance. Because the minute they talk, you'll already know from the beginning, from the onset, which formula is going to be utilized. And we're going to be using it through all our examples. We are going to be using it through all our examples today. Even the other one that I said, that missing payment one, it's also going to be with the same acronym, FSPL. All right. Onliners, we good? Right. Yes, thank you, Megan. Thank you. Of course, Amir. Did you just join us now? We've been saying it. Of course, we're doing paper 2. Right. Seems like you just joined us now. Right, let's go. Let's finish up with this. Okay. Now we take out, let's say we took out a loan. Right. You took out a loan. So now we're going to do future value present. We're going to go according to that mind map that I gave you. So we're going to go through future value, present value. We're going to do balance outstanding. We're going to do trade-in. We're going to do immediate payment, deferred payment, final payment, missing payment. And that will conclude finance for today. Right. So let's take out a loan. Let's make up an amount. You took out a loan for 800,000 to buy an apartment. You took it over 20 years at an interest rate of, our current interest rate in the country at the moment, I think it's about 11.2%. 11.2% per annum, compounded monthly. Right. Question number 1, calculate your monthly installment. Monthly installment. And let's say you stop paying after 15 years. So calculate the balance outstanding, calculate the balance. I'm doing 2 models here. I'm doing the present value, and I'm doing the balance outstanding. The balance outstanding after 15 years for the remaining period on the loan. So let's go. Very important concepts, guys. Very, very, very important concepts. Sunny boy is not understanding flippant stupid people. F, flippant stupid people. Future value for savings. Present value for loans, Sunny boy. This will help you to remember when to use which formula. Future value formula for savings or sinking funds. Present value for loans. Right, so we're taking out a loan immediately according to FSPL. We take out a loan. Which formula? Present value or future value? Thank you. So present value. PV is equal to X into 1 minus 1 plus I to the minus N all over I. PV, 800,000, is equal to, calculate your monthly installment, so they look for X, into 1 minus 1 plus your interest rate, 0,112 over 12, compounded monthly, to the power minus 12 times 20 years, minus 12 times 20, close brackets, all over I, 0,112 over 12. Let's solve for X. X is equal to, right. How do we make X the subject of the formula immediately? Where do I begin? Sorry? At the bottom. Yes, the denominator. Start here. Multiplied by the 800,000. Press equals on your calculator and then divide it with everything else besides the X. So let's go to our calculators. Let's start on the denominator. 0,112 over 12 multiplied by 800,000 equals, divide that by open brackets 1 minus open brackets 1 plus fraction, 0,112 over 12, close brackets, to the power minus 12 times 20, close brackets, equals, and I'm sure we all get the same answer. Call it out for me. 8,366,67 per month. Fantastic, you are right. Well done. Well done, well done, well done. Well done. Right, so here we go. 8,366,67 per month. So that was quite straightforward. They gave you a loan, you used the PV formula, you got X. Now let's see if you can do the next one, the balance outstanding. Now, your memos give you a long procedure, guys. Sometimes it's half a page or a page of calculation. You can do it in one step. You can use your PV formula and you can get it in one line. Let me show you how to do balance outstanding. Yes. Yeah, per month, because it's your monthly repayment. Right, pay attention here. Pay attention. So we've now got 8,366,67. I'm just going to write it here on the top. 8,366,67 per month. Right, so that was your monthly repayment. Now, guys, sometimes they can trick you. Listen to me and listen carefully. Sometimes they don't ask you to calculate the monthly installment. They go straight, calculate the balance outstanding after 15 years for 6 marks. You still have to first calculate the monthly installment, then calculate. So this is a very important concept. If they break it up like this for you, they've helped you. If they don't break it up and they just ask you question number 2, you still have to do question number 1 by default. Right. Let's answer the second question, guys. Let's answer the second question. Calculate. Now, they can either tell you after 15 years or after the 150th payment. Makes no difference. Watch here. Answer to question number 2. Balance outstanding, PV, is equal to X into 1 minus 1 plus I to the minus N all over I. In this case, for balance outstanding, we're looking for PV. PV is your balance outstanding. So PV is equal to X, which we just found. Do you see how important is it for us to have done number 1? You had to have done number 1 to be able to answer question number 2. So 8366,67 into 1 minus 1 plus your interest rate 0,112 over 12 to the power negative. I'm going to leave that open all over I, 0,112 over 12. To get your n here, guys, to get your n, pay attention. To get your n value here, you take your full term, including your compoundings, minus your paid up term. F minus P means full minus paid. Right? Your full term minus. So what's your full term? So it's 20 times 12. Minus your paid up term is what? 15 times 12. So there we go. 20 times 12 is 240. Minus 15 times 12 is 180. Your outstanding number of payments is 60. You got 60 payments outstanding for the next 5 years. So you can do that. Write that in pencil, F minus P. Full term, including your compoundings, minus your paid up term, including your compoundings. So your balance outstanding after 15 years on the loan, your balance outstanding. Right, so let's go. 8366,67. No, sorry. 8366,67. Open brackets 1 minus open brackets 1 plus fraction 0,112 over 12. Close brackets to the power negative 60. Close brackets equals. Divide that by 0,112 over 12. Boom. You still owe 383,048 Rand 99 cents. You always do it to 2 decimal places, so you look at the third number after the comma, after the decimal. Outstanding, and you must write outstanding. Don't just put 383,048, because they're asking you to calculate how much is balance outstanding. Okay? So there we go. Right, lovely guys. Lovely. Hope you guys all got this one down. We're now going to do a trade-in of an asset, machinery, equipment. A farmer buys a tractor, you buy a car, you want to trade it in after 5 years. Calculate now your trade-in value, book value, and the value of a sinking fund. So let's go. Let's say a farmer buys a tractor for 1.2 million Rand. Let's go. A farmer buys a tractor. So he buys a tractor. The tractor is 1.2 million. A John Deere. Right. He needs to trade it in after 5 years. Right. For a new tractor. Right. It depreciates, the old tractor depreciates at 15% per annum. The new tractor price will increase by inflation of 11% per annum. A sinking fund is set up that earns 9.3% per annum, compounded monthly. Calculate the monthly repayment into the fund for 10 marks. Right, here's a 10-mark question, guys. Yes, 10 marks. You know why? Because it's done in certain parts. It's done in certain concepts, key concepts that we need to first calculate. It's done, these type of problems, guys, the trade-in model is done in how many components? 4. It's done in 4 components. A question like this is done in 4 parts. A question like this is done in, for the outstanding balance, do we also subtract payments? Must? No, 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 no. That we're going to do the missed payments. Again, Ululuto, you are jumping the gun here. You are confusing all the things. Let's go through it in step by step. We busy now with the trade-in. We'll get to the missed payments model. The missed payment model is the last one. Right, let's go. Right. The first thing we need to do is we need to calculate the book value or the scrap value of the old tractor. And that is A equal P into 1 minus I to the power N. So that would be 1,200,000 into 1 minus depreciation. Now scratch it out because you're never going to use that amount again. 0.15 to the power 5 years because it needs to be replaced or traded in how many years' time? 5. This will give me, let's go to our calculator, 1,200,000 into 1 minus 0.15 close brackets to the power 5. We now get the book value, the scrap value is 532,000. That's all that the bank will give him or the wherever he's going to be trading it in at, they will come at 375. Let's not round it off here. We'll round off right at the end. So step number 1 is calculate the book value. Step number 2 is calculate the new price of your new tractor. And your new price is inflation, and inflation is compound increase. So that is, you take the full amount. You don't take the book value. You take 1,200,000 into 1 plus your inflation rate is 11%, 0.11 to the power 5. And what amount do we get there? Let's go to our calculators. 1,200,123 into 1 plus 0.11 close brackets to the power 5. Boom. Sure. 2,022,069 Rand 786. It's a Muslim dealership. You get a 786. If a 786 comes in there, your Muslim jumps. God loves me. Right, here we go. So we got 786. 786 is a code. Right, here goes. So this was your book value. That was your new price. Now you need to calculate the value of the fund that you need to set up. Value of fund. Guys, learn these processes. Learn these processes. So now value of the fund, you're going to take that minus that. So 2022069,786 minus 532,446,375. And that is going to give me, let's go, 2022069. No, 2022069.786 minus 532,446,375. And we get 1.4 million, 1489, 1489, 623,411. That's the value of the fund. Now you're opening up a sinking fund. So it's a savings. What formula from flippant stupid people? FSPL, future value or present value? So right, now we need future value. Now we use the future value formula. So 1489, 623,411 is equal to x into 1 plus 9.3%, 0.093 over 12 to the power 12 times 5 minus 1 all over I. 0.093 over 12. Here's your final answer coming up, your monthly repayment into your fund. Now, somebody asked in the comments, please, sir, how did you calculate X? So let's show you again how to make X the subject of the formula. We're isolating X. So start at the bottom. Multiply it and divide by everything here. So let's go to our calculators. 0.093 over 12 multiplied by 1,489,623,411 equals, divide that by open 1 plus fraction 0.093 over 12 close brackets to the power 12 times 5 is 60 minus 1 close brackets. Don't forget to close brackets at the end. Here's your final answer. Moment of truth for 10 marks. 19,594,889,89. Well done. Per month. So he needs to put in about 20,000 Rand a month over the next 5 years, plus his current tractor. He'll give it in and he'll get a brand new tractor after 5 years. Yes or no? Guys, learn these four. Book value, new price. Value of fund, future value. That's how you do this trade-in model. Here we go. No, you don't round off. You only round off at the end because you don't want to lose out on any rands or cents at the end. Book value, new price. Value of fund, future value. 4 parts. Right. Let's now do, so we did trade-in. So according to our mind map that I gave you this morning, we now need to do the immediate payment. Remember, if you take out a loan today, is your first payment due today or at the end of the month? Correct. Now, what happens now if you take out a loan and you pay today? How does that affect? How does that affect your monthly repayment, your new monthly repayment? I'm going to show you like we did. Guys, these are templates. I'm going to show you these different models. You just learn the art of doing these models. You will never get them wrong in your exam. So let's go. We're now doing the immediate payment. Pay attention here. So now we take out a loan. Let's say we take out a loan for 900,000. We take it for a period of 10 years. And let's say our interest rate is 13.2% per annum, compounded monthly. Right. Your first payment is made immediately, like the day you took out the loan. First payment is repaid on the day you took out the loan. On the day the loan was taken out. Calculate your new adjusted monthly repayment. For 5 marks. Right. No, we are not doing trade-in again. You learn the model I gave you. That's it. If I do 10 examples of each type, we'll never finish today. The models that I give you are templates. You go home and memorize it. And tonight or tomorrow, you re-watch this session on YouTube. Do it over and over and over again. till you master the concept. Guys, to give you an explanation, these models that I'm sharing with you are my own notes that I use to master mathematics. I only learn one model of each type. So I ask myself, in this topic, in how many variations can the question be asked? And I learned those models. I memorized the models. That's how I'm able to answer an entire paper. Right. Now pay attention. Guys. So it's PV because it's a loan. But you took out a loan for 900,000, but you made your first payment immediately. So your loan amount is not 900,000. It's your loan amount is 900,000 minus your first month's payment. Yes or no? So watch here. Pay attention. So your loan amount is PV minus X is equal to X into 1 minus 1 plus I to the minus N all over I. This is your new loan amount, please. Now this is where it takes a bit of a change. Pay attention. Pay attention, guys. Pay attention. Now we need to solve for X. Remember, we need to solve for X, your new adjusted monthly repayment. We're still solving for X. Now, how do we solve for X here, guys? We take the minus X, we take it on the other side. So watch what happens. Put your pens down. Watch here. Otherwise, you're going to get confused. So PV is equal to X into 1 minus 1 plus I to the minus N all over I. The minus X from this side will come on this side as plus X. Yes or no? Now, I want X on its own. I got two terms. What did I tell you yesterday? Whenever we got two terms and we got something common, what do we always take out? Highest common factor. Yes or no? So PV is equal to, take out X as your highest common factor. We left with 1 minus 1 plus I to the minus N all over I plus, we take X. We took out X from X. What am I left with? There we go. That's where the 1 comes from. So you add in you do it just like this. You manipulate the formula. Now here's your PV. 900,000 is equal to X into 1 minus 1 plus, what's your I? 0,132 over 12 to the power minus 12 times 10 years, all over I. 0,132 over 12 plus 1. I want X on its own. So basically, in algebra, what would we do? To get X here on its own, we take the 900,000 and we divide it by that entire bracket there. So X is equal to, now guys, you guys will be sharp here. So go to your calculators, press your fraction key, put 900,000 in your numerator, come down, open brackets, put your fraction key again. Now in your numerator, 1 minus open brackets 1 plus 0,132 over 12. Close brackets to the power minus 120. Minus 12 times 10 is minus 120. Over, fraction again, 0,132 over 12. Go to the side, plus 1. Close brackets, equals 13,343 rands 53 cents per month. That's your new adjusted monthly repayment, and you will get 5 marks for that. Please learn. That is your new monthly adjustment. Yes, Ahmed, we are going to be doing that. When you say do an example of interest paid up to a certain point, that's called the missing payment model. we're going to do last. That's our last model. We're doing if you were here from the beginning, you would have understood we are going through the mind map I gave in the beginning of the lesson. So we did depreciation, we did converting nominal to effective interest rates, we did present value, we did balance outstanding on a loan, we did immediate payment. We're now going to do deferred payment, final payment, missing payment. Right. You all got this? Why? Calculator work. Get your calculator work right. Get your calculator work right. Okay, I'm clearing the frame. This is how. You can see some people here are playing. They got time for jokes. How can you ace the topic? You ace the models I give you. You will ace the topic. Right, here goes. I'm clearing here. I am clearing here. So this is the immediate payment model. We're now going into deferred payment, where you pay late. Right. Again, we take out a loan. We take out a loan for 700,000. We take it over 10 years at 8.6% per annum, compounded quarterly. The first payment was made 9 months after the loan was taken out. Yes. 700,000. The loan amount is 700,000 over 10 years at 8.6% per annum compounded quarterly. The first payment was made 9 months after the loan was taken out. Calculate your new quarterly repayment. Pay attention. And it's worth 6 marks. So this is where you're paying late. Deferred, they don't use the word deferred. Sometimes they may use the word deferred. The first payment was deferred. You can't do that. You can take out a loan, phone the bank and say, please, I've got some financial difficulties or whatever the case may be, or and I'd like to pay in 3 months' time. I would like to. But obviously, this is the way they're going to calculate what your new adjusted quarterly repayment is going to be. Right. Okay, so what do we need to do here first? Now pay attention to this model. Pay attention. Pay attention. Let's go. Right. So you took out the loan. You took out the loan here, T0. You're making your first payment in 9 months' time. So 1, 2, 3, 4, 5, 6, 7, 8, 9 months' time. The first payment was made 9 months after, and it's quarterly. So 1, 2, 3. 3 months is your first quarter. 1, 2, 3 is your second quarter. And 9 months' time. So that means how many quarters do you have? 1, 2, 3 quarters. Right? 3 3-month periods between now and you made your first payment. Okay. You were supposed to make your payment here. You didn't. So you're going to get punished here. You were supposed to make your payment here, but you didn't. You're going to get punished here again. But then you made your last payment there, so you're not getting punished. So for how many payment periods are you getting punished? 2. Out of the 3, you're only getting punished for 2. You were supposed to make 1 here, you didn't. You were supposed to make 1 there, you didn't. You made 1 there. You're getting punished for these 2. So the first thing we need to do is to calculate your new loan amount. Write this down. So this is how you do the deferred payment. New loan, A equal P into 1 plus I to the power 2. So now you're going to take 700,000 into 1 plus, what's your interest? 0,086 over 4 to the power 2, number of payments. You get 2 payment periods you're getting punished for. So this will give me an amount. Let's go to our calculator. 700,000 into 1 plus fraction 0,086 over 4, close brackets to the power 2. We get your new loan amount now with interest for 9 months is 730,423 rand, 575. That's your new loan amount. Now you need to calculate your new quarterly repayment. So your new quarterly repayment, because it's a loan, is it future value or present value? It's a loan, present value. So PV. So in fact, let's just go straight into this. We're using our PV formula. 730,423,575 is equal to X into 1 minus 1 plus I, 0,086 over 4 to the power minus. I'm leaving that open for now because we need to make an adjustment there. All over 0,086 over 4. Now, how do I get my N here? 10 years multiplied by compounded quarterly is how many payments? 40 payments. How many payments did you miss? Minus 2 payments that you missed. So 40 minus 2 is what? 38. So it's to the power minus 38. So although you're increasing here by 2, but you're decreasing there by 2. Make sense? Obviously. Because you're paying a larger amount in a shorter period of time. You're paying a larger amount in a shorter period of time. So it makes perfect sense. So X now is equal to, let's go to our calculators. Start in the denominator, 0,086 over 4 multiplied by 730,423,575 divided by open brackets 1 minus open brackets 1 plus fraction 0,086 over 4, close brackets to the power minus 38, close brackets equals 28,326. Here's your final answer coming up, guys. 28,326, 139,14 per quarter. And there's your final answer. There's your final answer. That's your deferred payment model. That is your deferred payment model. So we did immediate payment, we did trade-in, immediate payment, deferred payment. Let's do final payment. Very important. The next concept is very important. Final payment. Philemon, we're not delaying by 8 months because it's not compounded monthly. To answer Philemon, it's not the delay of 8 months. If it was compounded monthly and you paid in 9 months' time, then it's delayed by 8. You subtract 1. But this is quarterly. So between now and the end of 9 months, there are 3 quarters, but you minus 1 from there. So you get punished for 2 quarters. You know compounded quarterly? It's 9 months. We got 3 quarters in 9 months. 12 months compounded, an amount delayed for 12 months, compounded monthly, then it would be 11. You get punished for 11 payments. It's your total minus 1. Yeah, just 1. 1 payment. You paid in 11 months' time. So that means the first part here, just to explain to you, the first part here would be to the power 11 because you're paying in 11 months' time. But here you would subtract 11 from the 40. 40 minus, depending on how many payments you had, you minus 11. Right. So this is the deferred. Let's now go into the final payment. Let's go into final payment. Right. So here goes final payment. You buy a bus and your bus is 800,000. Your repayment is 10.5% per annum, compounded monthly. You decide to pay in 24,000 Rand per month. So you buy a bus for 800,000, you pay in 24,000 Rand per month, 10.5% per annum compounded monthly. Question number 1. How many payments will be made to pay up the bus? How many payments? How many payments will be made to pay up the bus? That's 4 marks. And number 2, calculate the final payment required. Here the key word is final payment. Required to pay up the loan, to repay the loan. And that's 6 marks. So 4 and 6, total marks 10. This is called the final payment model. So let's do this. Let's answer the first question. How many payments will be made to pay up the bus? Come on, you guys can work this one out. It's PV. You've taken out a loan. They're giving you your X. So they've given you PV and they're giving you the X. You're looking for N. How many payments? You're looking for N. So this is definitely 100% a log question. To answer Pabalo, thanks Oratile, because he missed the first 2. Yes, he missed the first 2 payments. There were 3 payments. There were 3 payments in 9 months because it was compounded quarterly, and he missed 2. Right, here we go. Go for it. How many payments? So now we're going to go PV. We're going to say 800,000 is equal to 24,000 into 1 minus 1 plus I. I is 0.105 over 12 to the power minus N all over I. 0.105 over 12. Right. Now we need to make N the subject of the formula. So we start here at the bottom. We start there and we multiply it by there and we divide it by 24,000. So let's go to our calculators. 0.105 divided by 12 multiplied by 800,000. We get 7,000. Divide it by 24,000. Then we are left with 1 minus, now let's do that in the brackets. 1 plus 0.105 over 12. 807 over 800. 807 over 800. To the power minus N. There we go. Take the 1 over. So 7,000 divided by 24,000 minus 1 equals minus 17 over 24. I've already sorted out that. Is equal to minus 807 over 800 to the power minus N. Now negative and negative will cancel out. So minus n log 807 over 800 is equal to log 17 over 24. Minus n will equal to log 17 over 24 divided by log 807 over 800. Minus n will equal to, let's go to our calculators, log 17 over 24 divided by log 807 over 800. You get minus 39,58, minus 39,58. Now negative and negative cancels out. So you will make 39 full, in total you'll make 40 payments, but you'll make 39 full payments of 24,000. So you will make, how many payments will be made to pay up the bus? This is how you will answer it. Now, after you've done that, you will say 40 payments, 40 payments, 39 full payments of 24,000, 24K, 24,000, and one payment less, one payment, and one payment less than 24,000. That's it. 40 full payments. Yeah. 17 over 24. That over that minus 1. Remember, I'm taking over the 1. There you go. Guys, this is a template. You can answer it in your paper exactly the way I've done it here on the screen. Now, calculate the final payment required. Guys, this is also the final payment broken up into parts. The final payment is also broken into parts. So watch here. Watch how we do the last part. Watch how we do the last part. You all got this? Good. Let's just open up a new page here. Right. We now want to calculate the final payment required. So what you do, this is how you do the final payment model. Final payment. Right, final payment. You calculate the bank's amount. Then you calculate your amount. Then you subtract the two. Then you add 1 month's interest. Guys, sometimes your memos will do this all in one calculation. You won't know whether you Arthur or Martha. You won't know where you're coming or going. Don't follow that. Break it up like this. Break it up like this, bite-sized pieces. You'll always get the answer right. You will always get the answer correct if you follow these 4 steps. The bank's amount is A. You see, bank uses A equal P into 1 plus I to the power 39. Because 39 full payments. Your amount, because you are putting in 24,000 every month, it's future value. Because you want to see how much it's going to build up to. So now you use future value is equal to 24,000 into 1 plus I to the power 39 minus 1 all over I. Now you subtract the two. The answer to this minus, or the bank's amount minus your amount. You subtract the two to get that amount. Now add 1 month's interest, A equal P into 1 plus I to the power 1. 1 month, 1 payment. Let's see you work this one out. Let's see you work this one out. Come onliners. We use logs. We use logs. In the previous one, I'm answering one of the learners here online. Can you please explain how we got n? N was in the power. We have to make n the subject of the formula. Get your algebra right. Use logs. Right. While you're doing this one, I'm just going to look for that question about the missing payment one. Here we go. I got it. Right. Right. So your bank's amount, your final payment was remember you took out a loan. Your loan was how much? 800,000. Am I right? 1 plus what was your interest? 10,5, 0,105 over 12 to the power 39. That would give you an amount 800,000 into 1 plus fraction 0,105 over 12, close brackets to the power 39. You would get 112,3694,741. Your amount for 24,000 for 39 payments is going to be, your I is still 0,105 over 12 over I, 0,105 over 12 to the power 39. And that will give you, let's go to our calculators, 24,000, open, 1 plus fraction, 0,105 over 12, close brackets to the power 39, minus 1, divide that by 0,105 over 12, you get 1109,810,542. Now there's a difference between the two. That's why we subtract. So now we take 112,3694,741 minus 1109,810,542. We get 13,884. This is your one amount less 24,000, 199. Now we add 1 month's interest to this. So this is 13,884. Can you see? I've cut out a template for you. All you do, you follow the template, you're going to get straight to the answer. 199 into 1 plus 0,105 over 12 to the power 1. I'm putting a 1 there just to show you it's 1 month's, one payment interest. Multiplied by 1 plus fraction 0,105 over 12, close brackets, boom. This is the last final payment less than 24,000. 14,005,685,69. Final payment. And there we go. This is 1 month's interest. So your bank's amount, your amount. Bank's amount, that's your straightforward compound interest. Your amount, future value. Subtract the two to get that. 1 month's interest to the power 1. Easy. Straightforward. Now it's easy. If you were sitting in the exam and they just threw you into the deep end, how would you break all this up? And this is about 6 marks. 2 marks for each part. 2 marks for each part. Don't mess it up. Don't mess it up. How's our onliners doing? Sitembile Matiso. Well done, well done, well done. Sabza asked the question, why did we subtract 900,000 minus X? Because you made your first payment immediately. So your loan amount, say you paid in 20,000 Rand immediately. Your loan amount is not 900,000. It's 900,000 minus the 20,000 that you put in. That's why we said 900,000 minus X. Your new loan amount is not 900,000. It's 900,000 minus X. Oh, Frosty, your school didn't do finance. You are in trouble. As long as you learn all the models that we've done today, you will be fine. You are skibbity toilet. Right, here goes. Here's the missed payment model, guys. We are at the end. It's already 10:15. It's already 10:15. We're going to do this missed payment model. Then we're going to go for a break. That's it for finance. We come back. We're going to start with analytics and trigonometry immediately after the break. Right. I'm clearing the frame. Let's go into the missing payment model. The missing payment model. Take this down, guys. This is the last one. Right, so let's see. From a past paper, exactly 10 months ago, a bank granted Jane a loan of 800,000. So Jane took out a loan for 800,000 10 months ago. Shh, quiet. Take this down, guys. 10 months ago. At an interest rate of 10.25% per annum, compounded monthly. Take this down. It must be repaid over 20 years. To be repaid over 20 years. Must be repaid by means of monthly repayments of. So now they give you the monthly repayments. 7853,15, starting 1 month after the loan was granted. Question number 1. So a loan was granted for 800,000 10 months ago at 10.25% per annum compounded monthly. It needed to be repaid over a period of 20 years, and they gave you your X, your monthly repayment, starting 1 month after the loan was granted. So that means it wasn't an immediate payment, it was a normal loan. Right. How much did Jane owe immediately? So here's 2 questions, one for 4 and one for 5 marks. This is the last question that we are doing in finance, and then we are going for breakfast. Right, yes. How much did Jane owe? How much did Jane owe after making her 6th repayment? After her 6th repayment. Right? That's question number 1 for 4 marks. The next question. Due to financial difficulties, Jane missed. So here we go. Here comes the missing payment. She missed the 7th, 8th, and 9th payment. The 7th, 8th, and 9th payment. This is very important, guys. Pay attention to this missing payment model. This is a recurring one. This is new. They love asking this one. I've seen it now in all the provinces this year. Even in the exemplars of this year, this missing payment model is keep on popping up. I got a feeling missing payment is coming out in your prelim. Just a feeling. She was able to make payments from the end of the 10th month onwards. She continued to pay from month 10 onwards. She continued to pay from month 10 onwards. Right. Calculate Jane's increased monthly payment in order to settle the loan in the original 20 years. Calculate Jane's increased increased or adjusted monthly repayment. Why? Because she missed repayment, so now they're going to adjust it. Increased monthly repayment to repay her original loan over 20 years. Four and 5, 9 marks for these two questions. So the first one, after the 6th payment, that's straightforward balance outstanding. Go for it. Let's see how you guys do. I'll give you guys 5 minutes. It's 20 past. I'll give you guys 5 minutes to try and crack it, and then we'll work out the memo. So try it, guys. Apply your minds. How's our onliners doing? May you also show us how to calculate the total interest paid under the finance grade? Ooh. I don't understand. Your total interest paid, if you took out the loan for 800,000 and you were paying 24,000, you multiplied by 12, multiplied by 10 years, whatever your final amount that you repaid minus your capital amount will give you your interest paid. Instead of saying 900,000 plus X, can you just add 1 to the n value? No. You got to add that plus 1 as a whole integer value at the end, Masia, because you needed to take out X from X to give you 1. You're not adding 1 to the... Check it. I don't think it will give you the... It will never. No, I've never seen that before. But if it gives you the final answer, that means you've taught me something. If you just add 1 to n and you get the same answer, exactly the same answer, means you've taught me something. I doubt it. I doubt it very much. Try it. That's what we do in math. We make a hypothesis and then we test it. And if it works, it becomes a theorem, becomes a law. Try it, guys. Try it. Okay, so the first one is a straightforward PV balance outstanding. After her 6th repayment, that means, remember, her N will be now what? 20 years times 12 is 240 payments minus 6. That means will be to the power minus 234. Yes. Oh. Did you forget what we just did like 5 minutes ago? Maths is not mathsing. 7 minutes, yeah. We got 7 minutes to go before break. We're going to take a 30-minute breakfast break at 10:30. We come back and we are starting with paper 2. Right, here goes. For the first question, PV is equal to X into 1 minus 1 plus I to the minus N all over I. So it's outstanding. So they gave me this amount. So PV is your balance outstanding. What was your X amount? 7853,15. 7853,15 into 1 minus 1 plus I. What was it? 10,25. Am I right? 0,1025 over 12 to the power minus, I'll get to that now, all over I, 0,1025 over 12. To get this, your full term was 240 payments. Minus 6 payments. So that's minus 6. That gives you what? 234. There's 234 payments outstanding on her 20-year loan. So now you take 7853,15. Here's your balance outstanding. 1 minus open brackets 1 plus fraction 0,1025 over 12 close brackets to the power minus 234 close brackets equals. Divide that by fraction 0,1025 over 12, boom, 793,749,25 outstanding. So there you go, you got your first 4 marks. Now try the next one. Now remember, she stopped paying after the 6th payment. So at this point, okay, let's just draw a quick timeline here. Guys, let's just draw a quick time, and you can do this in the exam as well. Let's just draw a quick timeline to have a picture of what we're doing. This is now, this is in 20 years' time or 240 payments time. 20 years, 240 or 20 years. So after 6 payments, 1, 2, 3, 4, 5, 6, that's where she stopped paying. Now the balance outstanding for that amount was 793,749,25. Now she missed the 7th, this is after the 6th payment. She misses the 7th, the 8th, and the 9th. Am I right? Is that what the question says? Yes. She misses 7th, 8th, 9th. Obviously, the bank is going to charge her, is going to punish her with interest until there. So you need to get a new loan amount that she owes. So now she doesn't owe 793 anymore. She owes 793 plus 3 months interest that she missed. 3 payments. She missed the 7th, the 8th, and the 9th. How many payments did she miss? 3. So her loan amount after the 6th payment is no longer 793. It's 793 plus what we need to calculate. 3 months interest. Punishment. Guna. She's going to Jahannam. She's going to hell. Because she paid. She's getting punished. So the first thing we're going to do is A equal P into 1 plus I to the power 3. She missed 3 payments. This is going to be 793,749,25 into 1 plus 0,1025 over 12 to the power 3. This is going to give me this amount here. And that's going to be her new amount that's outstanding for the balance of the period. Not for 240. It's 240 minus all of this. Right. So what does that give us? How much does she owe? Isn't it now 814,263,3052? Very good. This is what now Jane owes. Now calculate her new monthly payment. So now this is PV again. So you have to do this first part. You're going to get 3 marks for that. If this is 6 marks, you'll get 3 marks for this. 814,263,3052. Now calculate your PV, her new adjusted. Work it out. I'm just erasing this at the top. This is where we're wrapping up before we go for tea time. Right, so now we're answering question number 2. PV. So PV is how much? That 814. So let's put it there. Now she owes 814,263,3052 is equal to X into 1 minus 1 plus 0,105 over 12 to the power minus. We need to do an adjustment of number of payments divided by 0,105 over 12. Right. She started paying from her 9th payment onwards. Remember, 6 payments, she missed 3. 6 plus 3 is how many? 9. So 240 minus 9 is how much? 231. There we go. How did I get it? I'm just going to write it here. How did I get that 230? It's your 240 minus your 9 payments. How did I get 9 payments? 6 payments plus 3 payments. 6 here. Here's your first 6 plus your 3. That will give me my 9 payments. 240 minus 9, which now gives me 231 payments. And here we go. We're now going into break. X is equal to, let's work it out. What does this work out to? I've got no idea. 0,105 over 12 multiplied by 814,263,3052 divided by open brackets 1 minus open brackets 1 plus fraction 0,105 over 12 close brackets to the power minus 231 close brackets equals. Here's your answer. Her new monthly repayment would be 8224,02 per month. Yeah? How? Can't be to the power minus 31. Let's go again. Let me try it one more time. 0,105 over 12 multiplied by 814,263,3052. Divide that by 1 minus open brackets 1 plus fraction 0,105 over 12 close brackets to the power minus 231 close brackets equals 8224. It's 10,25, 0,1025. Thank you. That's where I went wrong. Okay, my bad. Right, so what did you get? 8,000? 8,089. 8089,20 per month. Yebo. Boys and girls, that brings us to the end of our first session. Thank you so much. Hope you guys enjoyed finance. I think you should be solid with finance now. All these different models, you need to go home and practice. Okay. Onliners, our 7,000. I think we're on about 7,100 already. Guys, thank you so much. And we are going. Thank you, Atia. It was 10:025, not 10:015. Thank you so much. Guys, I'll see you guys back at 11 o'clock. Enjoy your break. Welcome back, all our learners, our 7,100 learners from across South Africa. Okay, guys, we're starting now. Yes, trig, angel, everybody's, I think this was the topic everybody was looking forward to for the trigonometry. So let's crack this in detail. We're going to push from now right through until the second break on trigs. We're going to crack this topic completely, and hopefully at the end of this topic, you'd be fully conversant and absolutely ready to answer your final exam. So onliners, how are we doing there? I hope you guys are still logged on. Right, lovely, already up. Best weekend with maths. Thanks, Mr. Kudus and Megan and Jaden. Let's go, let's go, let's go. Right, we're starting with trigs. These are the topics. Now, look, again, let's see what do we need to know in trigonometry. Right. Number one, you need to know how to draw up your Cartesian plane, right? So question number one, or your Cartesian plane. You need to know your Cartesian plane. The second item that you need to know, so this is when they give you a sketch. When they give you a sketch and you need to draw a Cartesian plane, then we need to know reduction. And reduction are your special angles, your 30-degree, your 45-degree, your 60-degree angles. Then we have your identities. We need to know your identities where you have to prove left-hand side equal to right-hand side. Right, so I'm giving you an overview of everything that you need to know for trigonometry, and then we're going to go into it question for question to make sure, and I'm choosing from 3 different past papers here. I'm sitting with November 2021, September 2023, and March 2018 papers. So I'll show you that if you can master the concept, no matter what paper, even if I had a stack of papers here, would make no difference. We'd apply the concept to it and get the answer correct all the time. So we got sketches, we've got reduction, we got identities, we've got general solution, where you need to solve for x. Here you need to prove, here you need to simplify, there you need to draw a sketch, and you can have trig substitution as well there. So substitution and Cartesian plane. So I'm just going to highlight that for you, underline substitution and Cartesian plane. That would all go under your sketch. Then you've got reduction, you've got identities, you've got general solution. Then you've got your non-90-degree triangles, guys. Your non-90-degree triangles. And that's your area rule. By now, your sine rule and your cos rule for non-90-degree triangles. Once you know this, you are completely sorted. 33 to 35, maybe 40 marks on trigonometry. Make sure that you get this right. We are also going to be doing Euclidean today, similarity and proportionality, and a little bit of grade 11 circles as well as analytics, circle analytics, where again, so if you score full marks in your stats, data handling, which is easy, 2 questions on analytics, your easy stuff, grade 11 stuff, 20 marks, grade 12 circle analytics, 20 marks, trigonometry, another 40 marks, and then another 50 marks on Euclidean. You will be okay for paper 2. I know paper 2, you guys said yesterday, paper 2 is giving you, it's rattling you a bit. I'll show you how nice it is to work with it. The 2 main things, what we need to learn for this is we need to learn incorporated in all of this. So let's put a big bracket here. Incorporated in all of this is your compound angle and your double angle. Please make sure you learn this, because everything in trigonometry is going to come down to compound and double, and I'm going to be showing you how to break it up, when to use which formulas in order for the variety of questions that I'm going to put forward to you. Right. So onliners, I hope you've taken this one down. I know this is your weakness. Makoma says this is my weakness. Hopefully this will be your strength. I love trigs. In fact, if you ask me personally, which are my 2 favorite topics, is calculus and trigs. My 2 personal favorites is calculus and trigs. Right, let's go. Compound angle, You get your sine compound angle. Now, because it's sine, it will help you to remember that when you break it up, it's going to be sine, cos, sine, and the sign stays the same. S for sine, S for stay the same. Then you put AB, AB. So sine of a compound angle is sine, cos, sine. The sine stays the same. The middle sign stays the same. So even if it was sine A minus B, you'd write sine, cos, sine, and that would be minus. For cos of a compound angle, I'm just going to write it here on the top. For cos of a compound angle, cos A plus B or A minus B, it's not sine, cos. Sine, you put sine first. Sine, cos, sine. For cos, you put cos. Sine, sine. And C for cos, C for change. So your sign changes. The positive will become a negative. Please remember that, guys. Sine of a compound angle, sine, cos, sine. The sign stays the same. Cos of a compound angle, cos, sine, sine. C for cos, C for change. We all okay with that? Get ready. We are about to get in. I'm going to do the double angles and then we start cracking the papers. And I'll show you we're going to get full 35, 40 marks. Total. All the time. All the time. So imagine you got full for stats, 20 marks. 40 marks for analytics, 20. So you're sitting with 60. You get full marks here. That's 100. 50 marks for Euclidean. Your grade 11 and your easy Euclidean is already 30 marks. So you can guarantee yourself 130 out of 150. Are you listening to me? Grade 12s, what can you do? You can guarantee yourself 130 out of 150 marks. That's our trajectory. That's where we're going today. Right, double angle. Double angle. So this was the sine of a compound angle. I'm just going to repeat that. Sine of a compound angle, sine, cos, sine. The sine stays the same. Cos of a compound angle, cos, sine, sine changes. The double angle. Now I'm going to do, now I know we only got double and compound. That's what you've been taught at school. I'm going to show you how to do the triple angle, 4 times an angle, and half an angle. All of them are being tested. What did I say? You get the triple angle, like sine 3x. Then you get sine 4x or cos 4x. Then you get sine half x, half an angle. Now we need to know how to manipulate all of that because you will see them coming up, popping up in your exams all the time. Your double angle, sine 2 times your angle or cos 2 times your angle. Sine 2a can only be broken up in one way. So whenever you see sine 2a, 2 sine a, cos a. But cos 2a can be broken up in how many ways? 3 ways. Notice something. Nowhere in this entire program am I using a formula sheet. So what does that tell you? You've got to memorize your formulas. You've got to know how to break them up. Because if you can't, you don't have time for every question to keep on referring to your formula sheet. Forget about your formula sheet as if it does not exist. You've got to know your formulas here to be able to break them up and work fast. So cos 2a is cos squared a minus sine squared a. Or that's if you want it in terms of cos and sine. Or if you want it only in terms of cos, it's 2 cos squared a minus 1. Or if you want it in terms of sine, 1 minus 2 sine squared a. So take that down. We're going to be using this a lot. A is your reference angle. When I say A, it could be X, it could be alpha, it could be beta, it could be theta. A is your reference angle. So 2 times your reference angle. Sine 2a, cos 2a. So sine of a compound angle, sine, cos cos, sine. I'm going to say it. I'm going to keep on repeating it so it sticks in your mind. You'll see when I start expanding the problems, I'm doing the same thing all the time. It's just repetition, guys. Sine of a compound angle, sine cos, cos sine, the sine stays the same. Cos of a compound angle, cos cos, sine sine. What happens? Sine changes. Double angle, sine 2a can only be broken up. So you must have this picture in your mind. Sine 2a can only be broken up in one way. 2 sine a cos a. But cos 2a can be broken up in how many ways? 3 ways. Cos squared a minus sine squared a. 2 cos squared a minus 1 or 1 minus 2 sine squared a. Are we all okay? You ready? Right. Brace yourself. Here we go. We're going straight into past papers. We're going straight into past papers. Right. Are you all good? Onliners, how are we doing? Are you fired up? Let's go. I'm clearing the frame. Right. Watch this. Watch this. Right. Now, I did tell you before that, I'm going to show you the triple angle, which is sine 3x. What to do with that? I'm going to show you 4 times an angle, which is like cos 4x. What to do with that? And I'm going to show you half an angle, like sine half x. What to do with that? Very important. So not only do we need to know the compound and the double, you need to know the triple, 4 times and half an angle. And once you know this, you are well equipped to go into this battle. Remember, it's a war. You need weapons. You can't go into a big war with a .22 or a gun or a BB gun. You're going to get destroyed. You need rockets to go into this war. Maths is a war. We're walking into a war field, but you need to be weaponized. And your weapons are these. Every topic has its own weapons. Let's destroy math. Let's smash math. Right, can I erase here? Have you taken it down? Let's go. If sine 38 equals P, without the use of a calc, and they tell you, and P is greater than 90 but less than 360. So they give you a restriction. Fine. Question number 1, cos 218. Number 2, cos 14. Question number 3, sine 26, cos 26 in terms of P. Okay, so let's take that out and let's see what is the strategy for attacking these type of problems. They'll always give you something like this. If sine 38 equals P, sine 24 equals M. You'll see that if you have been working through past, yeah? P greater than 90, less than 360. So we're leaving it here. Sine 38 is equal to P. That's exactly as the question is asked. Okay. So here goes. The first thing you do, yeah? So, watch it. No, the triangle. Let's see. Right, so here we go. Between 90, okay, just watch this. Just watch this. Right, so we got 90, 180, 270, 360. They say P is greater than 90, but less than 360. But where is P positive? Right? P is positive in our second quadrant only. That means we cannot draw it in our first quadrant. This triangle needs to be drawn because of my restriction. It needs to be drawn in my second quadrant. There we go. Now what we do is we call that 38. That's your reference angle. Now what you do is you convert that to a fraction, which is P over 1. You convert that to a fraction. Why? Because on the right-hand side of a trig fraction, of a trig ratio, must always be a fraction. SOHCAHTOA. Remember SOHCAHTOA? So sine is opposite over hypotenuse. So opposite is P. My hypotenuse is 1, and that is x. We now need to complete this diagram. We now need to complete. So you have to draw the diagram before you start answering the questions. Right. Let's go. Let's go. We now need to solve for x, so we're going to be used. So what you do, you can use what I call scrap. I call it scrap. Right. It's an acronym. Like I gave you in finance, FSPL, I'm giving you a new acronym. Standard form SOHCAHTOA. Standard form, there's it, standard form, opposite, standard form, and S for SOHCAHTOA. There we go. I put SOHCAHTOA, S-O-H. If it was cos, you'll put A-H. If it was tan, you'll put O-A. Cartesian plane, there we go. We've drawn our Cartesian plane. We look R for restriction to draw the correct triangle. A is just for n, and P is Pythagoras. Let's use Pythagoras to complete it. So if you remember this acronym in your mind, scrap. Check that it's in standard form. Use SOHCAHTOA. Draw your Cartesian plane. Look at your restriction to determine the right quadrant, the correct quadrant, and then use Pythagoras to complete. So let's use Pythagoras to find x. So 1 squared, I'm just using Pythag. 1 squared is equal to x squared plus p squared. 1 squared is 1 minus p squared equals x squared. X is equal to plus or minus the square root of 1 minus p squared. But it's to the left of 0. So it's minus the square root of 1 minus p squared. There we go. Now you've completed your diagram using scrap. Now you've completed your diagram using scrap. If you use this method, you'll never go wrong whenever you are drawing the Cartesian plane. Right. Onliners, how are we doing? Are you following? Some of you have started it already. I hope you're getting it right. I hope you're getting it right. Let's go. Right. While some of you are taking it down, the rest of you can already start answering the questions. Okay, let's go. Yes? It's just and. In scrap, the A is just for and. So that doesn't mean anything. It's just standard form, Cartesian plane, restriction, and Pythagoras. Okay, let's go. Let's answer the first one. And I'm now going to I'm going to teach you how to do, pay attention. I'm now going to teach you through this how to do half an angle. So I'm going to give you one more to do. Besides this, I'm going to add on a question for you. I'm going to add on, and I'm going to say sine 19. Now, 19 is half of 38. 19 is half of 38. Now, this one could be 2 marks, 2 marks, 3 marks, 5 marks. Let's put a mark allocation. 2 marks, 2 marks, or let's make that 3. Let's also make that 3, and let's make that 5. 2 and 3 is 5, 10, 13 marks. Right, let's answer these questions. Question number 1, cos 218. What is the relationship between 38 and a quadrant or a special angle or a double angle? This is cos. This will be 180, a quadrant plus my reference angle of 38. Now, cos 180, the name stays. Remember, 180 and 360, you got to learn your rules of reduction. Cos 180 will remain cos 38. 180 plus is in my third quadrant. Cos in my third quadrant is negative. Yes or no? So that's minus. According to SOHCAHTOA, cos is what? Adjacent over hypotenuse. So adjacent, that's your reference angle. That's your opposite. That's your hypotenuse. That's your adjacent. So adjacent over hypotenuse minus the square root of 1 minus p squared over 1, which is still minus the square root of 1 minus p squared. And there we go. You'll get your first 2 to 3 marks on that. Right. Oh, minus into that. Yes, it's minus into that. So it's minus into negative. And that will be a positive. Please be careful. There we go. That's over 1. That's your first answer. Onliners, I hope you got that one correct. Onliners, I hope you got that one correct. Next one, cos 14. Cos 14. What are we going to do with cos 14? Let's go into cos 14. So where's my calculator? There we go. Fourteen is 90 minus 76. Cos 14 is the same as saying cos. I'm just thinking, look, I'm not working through a memo here. I'm doing it. I'm trying to find relationships here. So let's go. Let's do question number 2. You might, maybe some of you did it slightly different. I'm doing question number 2. So we're done with question number 1. We're busy with question number 2, cos 14. Cos 14, what I see is cos, I would say 90 minus 76. And there's a relationship between, now why did I use 76? Because there's a relationship between 38 and 76. 76 is 2 times 38. Yes or no? So now, cos 90, we'll change it to sine 76. Right? Cos 90, remember 90 and 270, the name changes to co-function. Cos to sine and sine to cos. Guys, are you following? Are you, yeah? Question? No. Good. Right. Sine 76 is sine 2 times 38. That's where I'm bringing in my reference angle. So this would be 2, that's your sine double angle. That would be 2 sine 38 cos 38, which is equal to 2. Sine 38 is P, because they want it in terms of P. They want all these answers in terms of P. So sine 38 is P. Cos 38 is minus the square root of 1 minus P squared over 1. And that's your final answer. You put the negative right in the front because they're all multiplied by each other. Let's see who can do number 3 and 4. Now, number 3 and number 4 is 8 marks. So that means if you got number 3 and 4 wrong, you would only get 5 out of 13. You laughing. That's 38%. You would have only got 38.4% for the question. If you get number 3 and 4 wrong, let's see. Let's see if you guys can do number 3 and 4. Come on, South Africa. Come on, our 7,000 learners. Let's go, let's go, let's go. Do number 3, do number 4. Do number 3, do number 4. And that's going to determine whether you're going to ace this question or not. Now look here. If you are a bit confused or you're a bit lost, sine 26, cos 26, what does it look like? Doesn't it look like your sine double angle, like 2 sine 26 cos 26? It looks like that, but it's not. So how can I make it look like that? By multiplying it by 2. Now, if I multiply it by 2, it just means that at the end, I must divide my answer by 2. So I can manipulate. I can play around with it. I can play around with it. That's the fun. So have fun. That was a very sarcastic affirmation. Let's go. Number 2, we got sine 26, cos 26. I'm going to multiply it by 2 because I can. And at the end, I'll just divide it by 2. So just give me back, I'll get back to my same answer. So I'm going to make it 2 sine 26, cos 26, which is my sine double angle, which is sine 2 times 26. That's my sine double angle, which is equal to sine 2 times 26 is how much? 52. Now, watch here, watch here. If this is 38, isn't that angle there 52? Sum of angles of a triangle? Yes or no? So what is sine of this? Opposite over hypotenuse, which is, so now this becomes your opposite, that becomes your hypotenuse. So that's minus the square root of 1 minus p squared over 1, which is the same. So what's my final answer? Because I multiplied it by 2 in the beginning, therefore sine 26 cos 26 is equal to minus the square root of 1 minus p squared. Because I multiplied it by 2 in the beginning, I divide my answer by 2 at the end. And that's your answer. Yo, koine. Yes, lovely, beautiful, stunning. It's a work of art. Who got this one right? Onliners. One person got it right here. And don't lie. No, I'm not saying you. I'm just saying. Right, do the last one. Do the last one. Sine 19. Now that's a cracker. That one can be up to 6 marks. The last one can be up to 6 marks. Come, guys. Right. We're done with that. We're done with that. So we got full marks there, full marks there, full marks there. Now we're busy with number 4, sine 19. Onliners, how are we doing? Is the last one bombing you? Sir, show us if you had half of sine of a double. Yeah, that's exactly what I'm about to do now. This one here, sine 19. Right, now watch here. I'm teaching you. Right, put down your pens. South Africa, put down your pens. Nice to say that. I always wanted to say that. South Africa, stop. Right, pay attention. Pay attention. Sine 19. You start with cos of the double angle. Listen. Just listen to what I tell you. Whenever you have half an angle, start with cos 38. Start with cos of the double angle is equal to, and we know cos of 38 is minus the square root of 1 minus p squared over 1. Right. That's where you start. That is your beginning. Right. Pay attention. Why do I start off with cos 38? Because I can break the cos 38 as cos 2 times 19, my double angle, minus the square root of 1 minus p squared. Now, which of my cos double angles have got a sine in it? Isn't the last one? Remember, cos double can be broken up into 3. 1 minus 2 sine squared. Very good. So this is broken up into 1 minus 2 sine squared 19. Can you see? That's where we're getting the sine 19 is equal to minus the square root of 1 minus p squared. Now, all we have to do is make sine 19 the subject of the formula. So now take the 1 over. So that becomes minus 2 sine squared 19 is equal to minus into 1 minus p squared. Plus 1 will come on that side as minus 1. Now I'm going to divide both sides by negative 2. Yes? Yeah. I'm telling you, start off with cos of the double angle. Sine 19, start off with cos 38. Now cos 38 adjacent over hypotenuse is that. Yes or no? Right. Now break up the cos into 2 times 19, which is 1 minus 2 sine squared 19, and now make sine 19 the subject of your formula. That's your starting point. The most important part of this question is this part here, where you start off with cos of the double angle for half an angle. Right. Now divide that by 2, minus 2, divide that by negative 2. That and that will cancel out. I'm just moving over here to the side. So we now have sine squared 19 is equal to negative. This is over negative. That is over negative. So basically we have 1 plus square root 1 minus p squared over 2. Because the negatives will, this negative 2 belongs to both. Right? And now find the square root on that side. Find the square root. Here's your final answer coming up. Here's your final answer coming up. Therefore, sine 19, that's what they want, is equal to the square root of 1 minus the square root of 1 minus p squared all over 2. There we go, and you'll get 6 marks for that. Don't start. So now many of you might ask, but sir, why didn't you start off with sine 38? Right, so then you're going to have sine 2 times 19. Then you're going to have 2 sine 19 cos 19. But I don't want to cos 19. I only want sine 19. That's why I didn't use sine of the double angle. I use cos of the double angle. And the cos double angle has got one that has got a sine in it. Yes. It's 1 plus. There we go. Thank you. Yep. 1 plus square root. Yebo. Thank you. Why? Meaning?
As in sine 19 is 0.3255, and if you have the second answer, if it's 1 minus, it will also give you 0.3255. If it's 1 plus,
Yeah.
it's 0.9.
So let's just check. Let's just check our, let's do this. Let's check our algebra here. Cos 38 is cos 2 times 19 square minus square root of 1 minus p squared. Break that up. 1 minus 2 sine squared 19 is equal to minus the square root of 1 minus p squared. Take the 1 over, that becomes negative 1, right? There we go. Divide by negative 2, divide by negative 2. The negative and negative will cancel. Now, what this could be, it could be also written as this. It could be minus the square root of 1 minus p squared over minus 2 minus 1 over minus 2. So negative and negative will cancel out. That becomes a positive. That becomes a positive. That becomes a positive. So it's 1 plus the square root of that. And sine squared is equal to the square root of this whole thing. In fact, it could be plus or minus. It could be. Check with the minus in front of it. Still doesn't give it.
In fact, the answer in science, I think most of the answer in science.
Well, this is what the memo says. All right, take this one. This is the method of breaking it up. I'm showing you the method. We'll go through it. I'll go through it with you during the break. Right? But in any case, whenever you have sine 19, you start with cos of the double angle. The same thing would appear. The same thing would happen. Let me just put this way. Let's do this. Can I clear this frame? Right. Let's say you had to find sine 22, 5. Watch this one. Find sine 22, 5 without the use of find the value of sine 22, 5 without the use of a calculator. Right. For 5 marks. This is again half an angle because 22, 5 is half of which angle? 45. So watch here. Onliners, find sine 22, 5 without the use of a calculator. So again, to save you time, let's go here. We're going to start off with cos 45. Cos of the double angle. Now, you know this is a special angle, right? Which is root 2 over 2. That's your special angle. Right. Let's do exactly what we did in the previous one. Cos 22, 5 is cos 2 times, so cos 45 is cos 2 times 22, 5 is equal to root 2 over 2. There we go. Now we want sine from a cos double angle. So what am I going to now say? 1 minus 2 sine squared 22, 5 is equal to root 2 over 2. You following me here, Aiden? On this one here. Right. I'm using exactly the same concept. Now we have to make sine 22, 5 the subject of the formula. So minus 2 sine squared 22, 5 is equal to root 2 over 2 plus 1 will come on the other side as minus 1. Now you need to make this. So what we need to do is we need to simplify this right-hand side. So minus 2 sine squared 22, 5 is equal to, use your calculator, say root 2 over 2, root 2 over 2 minus 1, you get minus 2 plus root 2 all over 2. Remember, as long as we don't give our answer with decimals. Now divide by negative 2, divide by negative 2. So sine squared 22, 5 is equal to this, divided by negative 2. We get 2 minus root 2 over 4. Now we get rid of the square, find the square root, find the square root. So here's your final answer coming up. Sine 22, 5 is equal to the square root of 2 minus root 2 over, remember it's the square root of this whole thing, but 4 is a perfect square. What's the square root of 4? 2. There's your final answer. There's your final answer. We're using the same concept for half an angle. We're starting with cos of the double angle. You guys with me? Same concept. Exactly the same concept. Now, Aidan, what we can do is compare this one to the last one, and then during the break, we'll see where the discrepancy is. But this is the art of unpacking a problem like this. Right, watch this one. Watch this one. Let's go. Right, for those of you who have taken this one down, if sine 36 cos 12 equals P and cos 36 sine 12 equals Q, find. Question number 1. Sine 48. Sine 24. Cos 24. In terms of P and Q. In terms of P and Q. The first one is worth 2 marks, second one worth 2 marks, the last one worth 4 marks. Total marks 8. Go for it. Onliners, how are we doing? If it was half of cos, no problem. Then you just use 2 cos squared. To answer Sunny Boy, if it was half of cos, if it, say they wanted cos of half an angle, no problem. You can start it off with cos double angle. And you do have 1 in terms of cos. 2 cos squared minus 1. So just, you'll check which of the 3 the question requires. Sunny Boy. Right, Cassidy? Hope you're enjoying it. We're going through until 12:30. We're going through until 12:30. We don't have much time. Before you know it, it's break, it's lunch already. Right. What is the relationship? Watch here. If you don't know how to answer a question like this, how many of you are lost? Be honest. Right, watch. What is the relationship between the 2 reference angles and the question? What is the relationship between 48 and 36 and 12? That's the question you need to ask yourself in your mind. So the answer for sine 48, what is the relationship between 48 and 36 and 12? Is sine 36 plus 12. Yes or no? Compound angle. And here goes. Sine of a compound angle, sine cos, cos sine, 36, 12, 36, 12. For sine, the sign stays the same. Right. Now they're telling me that sine 36 cos 12 is P plus cos 36 sine 12 is how much? Q. And there's your answer in terms of P and Q. Was that difficult? No. Oh, now they're seeing. Now comes the eureka moments. Right, now do the second one. Now, I think by now you should know the second one already. Sine 24 would be 36 minus 12, which would be P minus Q. Yes or no? Right, so let's answer question number 2. Sine 24 is equal to sine 36 minus 12, which is going to equal to sine cos sine 36 12 minus, and that sine 36 cos 12 is P minus cos 36 sine 12 is Q. There we go. We got P plus Q, P minus Q. Correct. Now the last one. Now you can't say cos 24 is cos 36 minus 12, which it is, because then you're going to have cos sine sine. And you got no cos sine sine in terms of P and Q. You can't say 2 times 12. So you can't make it a double angle either. How would you do the last one? Now remember, if you got the last one wrong, out of 8 marks, you would have only got 50% for this question. You would have got the first 2 right. 4 out of 8. You would have lost 4 marks. And this is generally how tricks is. Like these questions, the first one will be a few marks, the last one. And let's test whether now you're going to get your distinction or not. Aiden, you worked it out. What answer did you get? Okay. 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 Right. Now we know, pay attention. Pay attention. Watch here. Watch here, watch here, watch here. Sine 48 is P plus Q. Sine 24 is P minus Q. We want cos 24, so we know these two are related. Right, watch here. I show you a little bit of magic. Look here. I'm answering question number 3. I want cos 24. Right. Don't we know, pay attention, don't we know from grade 11 that cos squared 24 is, if I squared this, according to my grade 11 identity, is 1 minus sine squared 24. Isn't this your grade 11 identity? Pay attention. Isn't cos squared x 1 minus sine squared x? Yes or no? You know sine squared plus cos squared is 1. So cos squared is 1 minus sine squared. So cos squared 24, pay attention, is equal to 1 minus, we got sine 24 in the previous one. Sine 24 is P minus Q squared. So therefore cos 24, because I squared it, I find the square root of it. Therefore, cos 24, I'm just finding the square root of it. Cos 24, that's what they want, is equal to the square root of 1 minus P minus Q squared. There's your final answer. Cos 24 is I'm using my grade 11 identity. If all else fails, refer to your grade 11 identity. There is another way of doing this as well. This is method number 1. I'm going to show you 2 methods, and both ways we're going to get the same answer. If you multiplied the same one, fantastic. Well done. Well done. Right, let me show you a different way of doing it. So this is method number 1, where I use the grade 11 identity. Right. So we're done with that. We're done with that. We're done with that. I'm now going to show you a different method. You've taken this one down? Right, watch here. Watch here. We know from, if you don't want to use the grade 11 identity, you know from your previous question that sine 24 is equal to P minus Q. Now, isn't P minus Q can also be written as P minus Q over 1, opposite over hypotenuse? Yes or no? So all I'm going to do, I'm going to draw a triangle. I'm going to call that 24 degrees. And opposite over hypotenuse is P minus Q over 1. And now I'm going to find, so now I'm going to use Pythagoras. 1 squared is equal to x squared plus P minus Q squared. 1 minus P minus Q squared is equal to x squared. X is equal to the square root of 1 minus P minus Q squared. So that means I now just solve for x. I solve for x, and x is the square root of 1 minus P minus Q squared. Therefore, cos 24 is equal to adjacent over hypotenuse. Adjacent over hypotenuse, the square root of 1 minus P minus Q squared over 1, which is still the square root of 1 minus P minus Q squared. So whether I used the grade 11 identity or I drew a triangle from my previous one, because 24 degrees was my reference angle, both ways I should get exactly the same answer. Right? Onliners, did you get it? Monday says they got it. No. Why would you use double the angle of sine? How is that going to help you? Huh? How? If what you said, sine?
Sine 48 gives you 2 sine 24 cos 24.
Oh, and then you just make cos 24 the subject of your formula. Okay. Did you get the same answer? As long as you got the same answer. Huh? But the same value. Okay. Yeah, no problem. No problem. So you saying if you used, okay, so that you say if we use sine 48. So let's just see. I'm just going to erase that. So you say, we say sine 48. Now sine 48 was P plus Q, right? So now you're going to say sine 2 times 24. If you're using that as P plus Q. And I'm just going along with the question that was asked. So this would be 2 sine 24 cos 24 is equal to P plus Q. Now you want to make cos 24 the subject of the formula. So cos 24 is equal to P plus Q divided by 2 sine 24. Which is cos 24 is equal to P plus Q over 2. Sine 24, we got it here as P minus Q. So now cos 24, one of the answers would be P plus Q over 2P minus 2Q. Well, that could be a possibility. That makes perfect mathematical sense. That makes perfect mathematical sense. I'm sure that would be one of the, look, that is not one of the solutions that they gave in the memo. But if your teacher was marking it, if the matric examiner was marking it, I shouldn't see a problem. Why? Because mathematically it's absolutely correct. I'm sure they would give you the answer for that. They would give you the marks for that. Makes sense? Makes perfect sense. So whoever did it that way, then well, if you use the one with Pythagoras, you'll get full marks, no problem. If you use the one using the grade 11 identity, you'll get full marks. And even if you use this one, you would still get the full marks, no problem. Remember something in mathematics, it's all about making sure that the steps that you use makes logical sense. Right, let's give you one here. They tell you, evaluate the following without the use of a calculator. 2 sine 165 cos 195 divided by cos 45, that's cos 45, sine 15 minus cos 15 sine 45. Simplify without the use of a calculator for 5 marks. Right, I must still show you 3 times an angle and 4 times an angle. I showed you half an angle. We're now going to do, after this, I'm going to show you 3 times an angle and 4 times an angle. Right. Guys, in stats, I'm not going to touch stats today because, stats, the only thing you need to know is your last year's standard deviation. You need to know regression of this year, which is all just calculator work. Line of best fit, y equals a plus bx, it will all be on your calculator, mode stat. If we have enough, after break, I want to do the Euclidean. I want to start with the Euclidean and I want to do probability. If we got time, we'll do stats. They will add more solutions. Thanks, VB. They will add more solutions during the memo discussion. So yes, you definitely will get the marks if it wasn't one of the solutions that was in your paper. Thank you so much, VB. You can't be tired. You have to work. You are writing your finals. This is like final exam, prelim exams, guys. Right, let's go. Let's go, let's go, let's go. So 2 sine 165, I'm going to convert that 165 and 195. I'm going to make that 180 minus 15 cos 180 plus 15 all over. Now be careful. You got cos sine, cos sine. There is no formula that has cos sine, cos sine. The formula that you know is sine, cos, cos, sine. So I'm just going to flip these two around. I'm going to make it sine, cos, sine 15, cos 45, minus sine, cos, cos, sine, cos 15, sine 45. That is equal to, now let's reduce this on the top, to sine 180, the name will stay the same, sine 15. 180 minus is in my second quadrant, sine in my second quadrant is positive. Multiplied by cos 180 will remain cos 15. 180 plus is in my third quadrant, cos is negative. Negative times is positive will make that a negative. I just brought the negative right through to the front. All over, be careful here, be careful. This is your sine compound angle. You need to pick that up. You need to look for that in your problems. Sine cos, cos sine is your sine compound angle. 15 minus, because for sine, the sine stays the same, 45. So minus on the top, 2 sine 15 cos 15 is your double angle for sine. So it's sine 2 times 15 all over sine 15 minus 45 is negative 30. So this is equal to minus sine 2 times 15 is 30 over sine of a negative angle is minus sine 30. Your answer is 1. Got it right? Well done. Your answer is 1. Somebody says, please do stats because geometry is easy. I don't know in which school they are, bruh. I don't know what maths they're doing. I don't know what maths they're doing. VB, what maths are they doing when they say, no, please do stats because geometry is difficult. Geometry is easy. Right, here goes. Let's give you another one to a single trig ratio. They gave you the March 2018 paper. Before I do the triple angle and 4 times an angle, let's give you this one to do. Do sine 180 minus x. Many of you will get this one right very fast, but they're just testing whether you know your rules of reduction. Plus cos 90 plus x. Cos x minus 180. This is beautiful. To a single trig ratio for 6 marks. Oh, this is going to test all your rules. This is going to test all your rules of reduction. Let's go, guys. Then I'm going to give you 1 or 2 right, now after this, we're going to do the triple angle identity, 4 times an angle identity, and another identity from a past paper. We're going to do 3 or 4 identities. Then we're going to do some general solution. Guys, before you know it, it's going to be lunchtime already. So work with us, learn these. Learn this. These are practice for your exams. Onliners, how are we doing there, guys? No, not mine. They want Euclidean. Salman in the house. They want Euclidean. Thank you, Kolani Tukula. Let's go, let's go, let's go. Right. Now, pay attention here. We need to sort that out. 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 Right, let's go. Deep breath. Sine 180 will remain sine x. 180 minus is in your second quadrant. Notice what I do. Every time I reduce, I check the quadrant. You must do that to see whether it's positive or negative. So 180 minus is in your second quadrant. There we go. So sine is positive. Cos of a negative angle is positive. Please do not take that negative outside. You don't get cos of a negative angle. A negative angle does not exist in a world of cos. Why? 360 minus or 0 degrees minus is a negative angle. Cos is positive. 0 degrees plus is in your first quadrant. Cos is positive. So cos of a negative angle. Don't ask me, sir, what happened to the negative sign? It falls away. It's positive. Right. Cos 90 will change to sine x, but 90 plus is in your second quadrant. Don't look at the changed one. Look at the original. Cos in your second quadrant is what? Negative. Be careful. Now, there are many ways of doing this last part. I don't know what method you guys use. I'm going to show you what method I use. Right. To do this last part, to do that last part, it's an anti-clockwise angle. So there are about 3 or 4 ways to doing it. I'm just showing you the method that I use. You can compare it to the way you use. You like my method, use my method. You like your method, stick with it. Right, pay attention. My method, all I do is I draw a Cartesian plane. I know cos 180. The name is going to stay cos x. Now I just need to determine whether it's positive or negative. Yes or no? Are you guys with me? If this was 90 or 270, I'll change it to sine. But because it's 180, I'm keeping the name. Cos is in which quadrant? Cos lives in which quadrant? Quadrant 4. I'm going to go 180 degrees anti-clockwise because it's x minus 180. So I'm going to go 180 degrees anti-clockwise. So from here to here is 90. From there to there is 180. Cos in this quadrant, it lands here. So cos lives in quadrant 4. He moved 180 degrees into another quadrant. He went to go and visit sine there. So is he positive or negative? Is cos positive or negative here where the star is? Negative. And negative times that negative makes it a? There we go. Are you with me? You like my method? Use my method. If you got another, there are other methods. Sure, the other method is quite long. You can make it, here's method 2. I'm just showing you method 2. Method 2, you can say cos, flip it over, minus 180 plus x. Then you don't take out the negative. You make it a negative angle in the bracket. Minus into 180 minus x. Now cos of a negative angle is positive. So it's cos 180 minus x. That falls away. Cos 180 will remain cos x. 180 minus is in my second quadrant. Cos in my second quadrant is negative. I get the same answer. Have you got another way of doing it as well? You can add 360 degrees as well to this. Minus 180 plus 360. So there are many, many ways of doing it. Just choose whichever method suits you as long as you get exactly the same result. Now what do I have? They say simplify to a single trig ratio. Sine cos. So now let's make the sine cos plus, swap these two over, cos sine. This is equal to sine cos. Cos sine is sine of my compound angle. Don't ask me where did cos disappear to. This is the sine compound angle. So that's sine x plus x, which is equal to sine 2x. Not sine squared x, sine 2x. There we go. You've simplified it to a single trig ratio. Now we're quickly going to do 3 times an angle and 4 times an angle. It's important for us to do that. Right, let's go. Are you done? Are you okay, guys? Onliners, how are we doing? Sine 2x, like a boss. Beautiful, glory, well done. Well done, Messiah. Well done, Blitzkrieg. Well done, well done, well done. Right, let's go. Prove. Now, this is a very common one. That's why I always do these ones at the workshops. Prove that sine 3x is equal to 3 sine x minus 4 sine cubed x. For 5 marks. Prove. So here's it, 3 times an angle. 3 times an angle. Now, let me show you what to do with this in your answer. Right? I don't have time. I wish I had time to, give you a question and wait for 5 or 10 minutes for you to do it. We won't go home. So let me do it for you. Just checking our time. It's 12:15 already. It's the last 15 minutes of our session. Right. I'll probably after break continue with 2D trigs. The 2-dimensional, remember you're going to get one like that for about 10 marks. That will be broken up. 2 marks, 3 marks, and 5 marks. About 8 to 10 marks, you'll get 2-dimensional or what they call 3D trigs or 2D trigs. Trigs on different dimensions. We'll do 1 or 2 of that after break, and then we'll go into Euclidean. Right, pay attention. Whenever you see 3 times an angle, so we start on the left-hand side. So let's say left-hand side. So we say sine 3x. We're going to expand it to look like this. So sine 3x is going to be sine. You break it up into compound. Pay attention. x plus 2x. Right. Now, if you break it up into compound, 1x plus 2x will give me 3x. Now, that's your sine compound angle. So what's that going to be? Sine cos sine x 2x plus x 2x. Yes or no? I'm going to put a tick there. You're all following? Guys, I'm only doing it once, so you better follow me step by step. I'm not erasing and I'm not re-explaining this one. So follow me step by step. Now, my right-hand side is only in terms of sine. So that means I need to get rid of that, I need to get rid of that, I need to get rid of that in terms of sine. So let's go. Sine x, copy and paste, sine x. Cos 2x in terms of sine is 1 minus 2 sine squared x, my double angle for cos, plus, this is cos x, can't do anything with that. This is one term, that's multiplied. Sine 2x is 2 sine x cos x. That's your double angle for sine. So now let's remove the brackets, guys. Sine x times 1 is what? Sine x minus, that's not a minus there, that's just a dot. Positive times negative is a negative. 1 times 2 is 2. Sine x times sine squared is sine cubed x. Right? It's like x squared times x is x cubed. Plus, this is one term. So that's 2 sine x. Cos x times cos x is what? Cos squared x. So I got sine, sine, sine. Where's my problem? Cos squared. Because I need it all in terms of sine. So let's break up cos squared. Sine x minus 2 sine cubed x plus 2 sine x. Cos squared, according to grade 11, is what? 1 minus sine squared. Good. Now remove the brackets. Again, sine x minus 2 sine cubed x plus 2 sine x times 1 is 2 sine x. Positive times negative is negative. 2 times 1 is 2. Sine times sine squared is sine cubed x. Now collect your like terms. 1 sine x plus 2 sine x is what? There's your answer coming up. 3 sine x. Minus 2 sine cubed x minus another 2 sine cubed x is what? Minus 4 sine cubed x, which is equal to your right-hand side. There we go. Done. 5 marks. Yes or no? Good. Well done. As long as you understand, practice on this one. It must be part of your toolbox, your mental toolbox. Guys, all our workshops are on YouTube. Those of you who just joined us today, you can always go through for the past 5 years. We've got enough hours for you. Different styles of questions. The more you put in your toolbox, the more equipped you're going to be. The less tools you have, the quicker you will finish your paper. Right, let's go. Last one. Here's another identity. Watch this. Cos 4x. Prove that here's 4 times an angle. 1 minus 8. This is another tool to have, a very good tool to know. For 5 marks, prove. Prove the following identity. Spot on, Cassidy. Let's go. I need your brain during the exam. Trust me, when you write your prelims immediately after that, okay, because I'm also heading up the maths department at a school, so I'm not able to. Otherwise, usually what I used to do is I used to go to a school, and while you people write your prelims or finals, I sit and write your prelims with you. So I go into another room and quickly, I want to see whether whatever I taught you came out, and I want to see if I can get 95%, and I give myself 45 minutes. 45 minutes to get at least 90. Then we know we still got 2 hours, 15 minutes to try and figure out the balance of the 10%. As long as I get 90 in 45, I'm a happy man. So like you guys, I will also be writing your prelim paper. The minute the learners finish the paper, I get a copy of the paper and I start working out the memo. It's my challenge. It's a small challenge I set to myself, just to see, just keeps me fresh. I want to see that what we did in the workshops, did it come out in the paper? And how would a grade 12 tackle it if they had just paid attention to the workshops, mastered the notes? Would they have got, how much would they have got? Then I can tell you after that, I'm telling you, you minimum, just from the workshops, you would get about 85. Right? I did half an angle, Boyson. We did half an angle already, brah. Boyson, did you just join us? Right, here we go. Let me show you how this one is done. Again, we're starting on the left-hand side. We expand that to look like this. There's nothing we can do on the right-hand side. Right-hand side is in its simplest form already. Cos 4x. Whenever you see, look, the previous one I gave you sine 3x. So I told you if there's a 3, you break it up into compound. If there's a 4, you break it up into double. Pay attention. So this is cos 2 times 2x. Now my reference angle is 2x. Please be careful here. Pay attention here. My reference angle, I'm going to circle it, is 2x. Cos of my double angle, my whole angle is 2x. Because 2 times 2x will give me 4x. Pay attention. Pay attention. Now this is where it starts getting a little, it starts going a bit pear-shaped. Belly up. Pay. Right, let's go. Pay attention. Cos of my double angle in terms of sine. My right-hand side is only in terms of sine. So cos of my double angle, and I'm going to circle that angle. I don't mind circling it 20 times. Cos of my double angle is 1 minus 2 sine squared of my angle. What's my angle? Thank you very much, not x. Right, pay attention now. This is now where many of you get confused. You don't know what to do here. So this is going to be 1 minus 2. You can't square a trig function. You're squaring the whole angle. So what you do is you make it like this, sine 2x, and bring the 2, the squared, to the top. Right, now let's break up that. 1 minus 2. Sine 2x is 2 sine x. That's my double angle. 2 sine x cos x, all squared. Now let's remove the brackets. 1 minus 2 into 2 squared is 4. It's one term. So it's sine squared x, cos squared x. Now let's remove the brackets. 1 minus 2 times 4 is minus 8 sine squared x, cos squared x. But I don't need a cos squared x in my answer. So 1 minus 8 sine squared x. Cos squared, according to grade 11, is what? 1 minus sine squared. Yes or no? Now let's remove the brackets. Here's your final answer coming up. 1 minus 8 times 1. There we go. Minus 8 sine squared x. Negative times negative is a positive. 8 times 1 is 8. Sine squared times sine squared is sine to the power 4x. Left hand side is equal to right hand side. Aiden, you did it the same way. Broke it up into double. Good. There we go, guys. There we go. Let's give you one more to do. One more. One more identity, and that takes us to lunch. One more identity, and that takes us to lunch. Onliners, I know you are cooked. Brain fried. Come. Yeah, why would you do Babongile? Why would you do sine 2x plus? No, cos 2x plus 2x, the thing is going to get big and ugly. I'm not saying you're wrong. I'm just saying just don't do it. Stay away. It's a trap. It's a trap. Right. Let's clear this one. Let's do the last one. So those of you who are done with this, I know some of you are still taking this one down. So those of you who are done here, you can start with this one here. Also from a past paper, prove that minus 2 sine squared x plus cos x plus 1. This is the last one before break, before lunch. 1 minus cos 540 minus x is equal to 2 cos x minus 1. Prove this identity. This one is November 2021. This one came out of the November 2021 national paper. November 2021 national paper. Come, we only got a couple of seconds left before lunch. Nah, I'm okay. I'm sharp. No. Let's go. Left hand side. Left hand side. What's going on here? Minus 2 sine squared x plus cos x plus 1 all over. I'm just going to simplify this first. 1 minus cos. Now, when we have an angle greater than 360, we can just subtract 360 from it, minus 360, which is 180, minus x. So, minus 2 sine squared x plus cos x plus 1 all over 1. Cos 180 will remain cos x. 180 minus is in my second quadrant. Cos in my second quadrant is negative. Negative times that negative is positive. So now this gives me a clue. Again, I'm telling you, I'm not working through a memo. I am not working through a memo, so I'm showing you how I would tackle it. This is the first thing that came to mind. Look, initially I didn't know what to do with the top. So that's why I left the top. I left that. I knew I could reduce this, so I reduced it. Now, what does this indicate to me? This indicates to me that I need to convert everything in my numerator in terms of cos. Why? Because then my denominator and something in my numerator will cancel out and I'll be left with my right-hand side. So at this point in time, I don't think I'm right. At this point in time, I know I'm right. So minus 2 sine squared x would be 1 minus cos squared x plus cos x plus 1 all over. And I know at a point I'm going to have to factorize because the bottom and the top, something at the bottom, something at the top must cancel to give me my right-hand side. All over 1 plus cos x. So if I multiply this out, this will give me negative 2 plus 2. I'm just doing it carefully so I don't make any algebra mistakes. Negative times negative is positive. 2 times 1 is 2 cos squared x plus cos x plus 1 all over 1 plus cos x. So now I'm left with, I'm just moving over here to the side. I'm left with 2 cos squared x plus cos x 1 minus 2 is minus 1 all over cos x plus 1. Cos x plus 1. Now, what did I say? That's a trinomial. Didn't I tell you I have to factorize? Now, because it has to, watch here, guys, watch here. Because it has to cancel out with something on the top, I'm just going to copy and paste cos x plus 1. Now, what will my other bracket be? 2 cos x. That will be my final answer, man. 2 cos x minus 1. Because if you multiply this out, you'll get back that. That and that will cancel out. I'm left with 2 cos x minus 1, which is equal to your right hand side. Same way? Did it the same way? Well done. Well done, well done, well done. We'll kick off with 1 or 2 general solutions after break, and then we'll do the 2D or 3D tricks. We're going to go now. It's 12:30 on the dot, 1:10 p.m. We resume. Okay? 13:10 we resume. Guys, enjoy your lunch break. I hope you guys enjoyed the session. This was a bit of a heavy session, but work that you need to learn. Right. Enjoy your break. Enjoy your break. Enjoy your break. Right. There we go. Enjoy your break, guys. Thank you so much. Right. There we go. Let's see that one.
One, two, 1, 2. 1, 1, 2.
You're still tuning in on Awqaf SA Grade 12 Maths Workshop Paper 2. I'm Khalid Kungane Kivaspadi, and with me is the maths teacher. You're teaching pure maths, isn't it? Here at the South Peninsula High School, and on his left, we've got Qiyam Talib from the Islamia College. They will be talking to us shortly about the benefits, and of this initiative, what it has sort of benefited them, and what are the means, they're trying to put in terms of making sure that the initiatives such like these, free initiatives, they continue and benefit our communities. And starting with you, Mr. Abdul Hakim, I believe you're the product of this particular workshop.
That's correct. Good afternoon, everyone. Assalamu alaikum. So I remember, I'm not going to give my age away, but I was a grade 10 student, and we just heard, we had this hype about this math teacher or math guru coming to do his rounds at schools. And we weren't very interested at first. And then eventually myself and my friends decided, okay, let's see what the hype about this KUA math is all about. And eventually when Mr. Kota did come to the school, was expounded us going to just explain after one presentation, I think it was all the hype and the fuss was worth it completely. So after that, I made it my intention to keep in contact with this guy. I followed him whenever I came to Cape Town. I invested in his DVD packs that they had. I kept in contact with him because I was so inspired after 1-2 hour lesson with Mr. Mohammed Kota under the banner of KUA.
And now we can definitely see the fruits, after all of that, the deliberations and so on. I know, because when it comes to seeing something new and initiative, not everyone jumps for the initiative, other people are doubtful. Is this the correct thing? Is this the right thing? How would you perhaps encourage someone who is looking at this Awqaf Maths workshop and they're still in doubt as to whether they should join it or something like that?
Look, firstly, you should be grateful that it's for free, because I mean, you get tutors asking 500 Rand per hour to conduct a math lesson privately. So it's about knowing, looking at the bigger picture and telling yourself that, look, math is a national issue. Okay. And if I'm given this tool or this resource to up my math, okay, at the cost of almost nothing, with a math guru, and people working behind the scenes, such as Mr. Khalid and Mr. Hasnain. I mean, I think you must grab the opportunity, okay? And obviously, we know it's no secret. Math opens doors for you, above and beyond, etc.
Just before I let you go, there's this notion that, pure math students are genius students, and maths lit students are students that are struggling. Which sort of now moves the support system away from the pure math students, because they are deemed, the genius and so on. How important is it that we make sure that we give this good support to the pure math students as well?
Also, it's about encouragement, it's about enliftment, it's about providing them with workshops like this. It's about taking them back to basics, because I always say that every difficult problem that you think exists in mathematics, it stems down from a very, very basic issue, which is learned at grade 5, grade 6, grade 8 level. Okay, so workshops like this, it emphasizes the importance of picking up on your basics. Okay, picking up on what you need to know in order to solve a more difficult problem. So I feel like the encouragement we can give is our workshops like this. It is what teachers do day in, day out, providing after school classes, interval classes, and that is a way in which we can encourage students to continue with pure math, which will ultimately open doors to them in the future.
And just to close, what sort of advice will you give to that student who still struggles? Because even on our online platforms, we still get messages, of students, they are lost, because I was talking to one of the students during the small break, and they were telling me that it's their first time seeing finances, so you do get those teachers, who are teaching or who focus on something else, So how would you say to those students, who have sort of encountered that challenge?
It sounds very cliche, but in mathematics, practice makes perfect. I mean, I always tell my students, just go home and set aside 10 minutes of your day to go over math. It doesn't have to be 2 hours, 3 hours. Take 10 minutes every day consistently. That's better than waiting for the exam and sacrificing 2 days without sleep. So I have a consistent pattern of practicing math every single day. 5-10 minutes, take it aside. And speaking of experience, if you feel like you're someone that has no hope, I've tutored students that came to me with 21%. At the end of matric, they ended up with a 60 or a 70. So there is hope. You can't say this is too much for you or you're not made for pure math. But I feel like all of us have something within us to succeed at it if we put our minds to it.
And that was Mr. Abdul Hakim Charles, a pure maths teacher here at the South Peninsula High School. And now we thank you very much for your time, sir. We speak to now Kiam. Kiam is a grade 12, a distinction prospect, so to speak, from the Islamia College in Imam Harun Road. Kiam, what was your motivation, coming to these kinds of sessions?
You see, so the first session that I came to from the Awqaf Foundation was this year, and my maths marks was like all the way down here, and then I came to a session and my maths marks was up. So yeah, it was good, very helpful.
Whatever you learn here, obviously, it's important to emphasize and try to make sure that you practice whatsoever you went through. So what you have been learning here, do you get time, to sit down and practice over it and sometimes, or even teach to those who are not here?
I think I do teach to my friends that need the help, but I don't get that much time to do it at home because it was studying for bio now.
Yeah.
Stuff. Yeah.
So, how is the maths the pure maths students in Islamia College? Give me a picture.
No, I think we're all doing pretty well because we have the best math teacher ever.
Yeah.
Mrs. Hassan, shout out Ms. Hassan, best math teacher ever. Yeah, she helps us a lot. She explains the work very well, stuff like that.
How encouraged are you now seeing that Mr. Abdul Hakim Charles, we just spoke to now, was also part of this program at some point in time, and he is now teaching pure maths here at the South Peninsula High School?
I think that's kind of motivational. It shows that this works and it's gonna help us. Yeah.
So just to close, which percentage are you aiming for at the end of?
I'm aiming for 100%, of course, because you see, I'm gonna give you guys an amazing quote that I like to live by now.
Yeah.
If you shoot for the stars, then you'll land. No, wait. If you shoot for the moon, and then you will land among the stars.
And that was Kiam Tolip from the Islamia College, giving us, one of the most important lines there. If you shoot for the
moon,
for the moon, you'll
land among the stars.
You'll land among the stars. So the 100% is the moon, and the stars is
70%.
Okay, that's where we'll end it. My name is Khalid Kungani Givaspadi. Until next time, we now give to Mr. Kota.
Thank you. That we are going back into session. What?
3 drops.
What?
I don't know. It's just not tricking. It's not like easy.
3 graphs are so easy.
The easy stuff on the begin to count principles.
We're going to try and see as much as we can. Right, welcome. Let's see, where are we? There we go, here we go, guys. Let's go. Welcome back. Right. Welcome grade 12s across the country and the learners of SP. We are now back into our third and final session for today. We're going to try and cover as much as we can in the little time that we have. Okay, let's go into 2D tricks from a past paper. In fact, let's do, let's see if there's a general solution here to do. Let's check if there's a general solution. Okay, let's have a look at this one here. They tell you give the general solution. Give the general solution. So they tell you, let's have a look, let's have a look, let's have a look. Welcome back, welcome back, welcome back, everybody. They give you 2 cos x is equal to 3 tan x. 2 cos x is equal to 3 tan x. And they want the general solution for 5 marks. This one is out of the March 2018 paper. Give the general solution. How's our onliners doing? Are everybody back? Can you guys hear me and see me clearly? Welcome, welcome, welcome back. Guys, we're doing the general solution. We'll do some 2D tricks. We can do some analytics and then we go into Euclidean. Right? Circle analytics. Here goes. Now the first thing that we need to do here is we're going to go 2 cos x is equal to 3. The tan x, we're going to make it sin x over cos x. We're going to convert the tan to sine over cos. Now I'm going to multiply this side by cos x and I'm going to multiply that side by cos x. That and that is going to cancel out. What are we left with? 2 cos times cos is cos squared x is equal to 3 sin x. Right, I'm putting a tick there, I'm putting a tick there. You all following me? You all settle down after break? I know your stomachs are lekker full. You guys had a lekker acne. Right. So 2 cos squared x minus 3 sin x is equal to 0. Now what we want to do is break the cos squared. So 2 cos squared is 1 minus sine squared x. From grade 11, minus 3 sine x is equal to 0. Multiply this out, you're going to get 2 minus 2 sine squared x minus 3 sine x is equal to 0. Whenever you see a square, we need to give 2 general solutions. So you'll be left with minus 2 sine squared x minus 3 sine x plus 2 equals to 0. Let's divide by negative. I'm going to be left with 2 sine squared x plus 3 sine x minus 2 equals to 0. Let's break this up. Let's factorize this. That's a quadratic equation, guys. So we got 2 sine x and sine x. I hope you're all working with me. Those of you that are working online, working at your schools, working at home, I hope you're all trying it together so that we are all on the same page all the time. Right. Now I'm going to make that 1 and 2. 1 sine x, 2 sine x, 4 sine x to give me a 3. And that would be plus, that would be minus. Right, now we have 2 general solutions. We've got 2 solutions, one on either side. We break it up. I'm just going to move over. I'm going to open up a new page just to finish this one up. I'll go back. I will go back. So we have 2 sine x minus 1. We have 2 sine x minus 1 into, let's go back, sine x plus 2. So we're going to have sine x plus 2 equals to 0. So you got 2 solutions. 2 sine x minus 1 equals 0. Or sine x plus 2 equals to 0. You're going to have 2 sine x. Let's solve for x is equal to 1. Sine x is equal to 1 over 2. Or sine x is equal to minus 2. This one will be no solution. because you know the maximum value of sine x is 1. So it can't equal to minus 2. Right? You can check it on your calculator. You can say shift sine -2, and it will give you no solution. On this side, x is equal to shift sine a half is 30 degrees plus k times 360, where k is an element of integers. Remember, for sine, we put k times 360, or for sine, we need to give two general solutions, 180 minus 30, second quadrant number 2. This answer is for quadrant number 1. This answer is for quadrant number 2. 180 minus 30 plus k times 360, where k is an element of integers, so x is equal to 150 degrees plus k times 360, or 360k, where k is an element of integers. And there we go. That's your one general solution. I'm going to give you another general solution problem to do in a different format, in a different style. Okay? Onliners, how are we doing? Let's go. Let's go back. There we go. We make it a quadratic equation. This is a simple quadratic equation. This cos squared is 1 minus sine squared. This is a quadratic equation. And we factorize. There we go. This is straightforward, guys. This is not rocket science. This is straightforward, not rocket science. I'm just thinking of one, a very popular one. Cos 2x minus 2 sine 2x, or is it 2 cos 2x minus sine 2x? Let's just check this next one. I'm going to do two more for you guys. I'm going to do two more for you. Please, guys, have your phones ready. If you're working on a big screen or whatever at home, take a screenshot if you feel that your handwriting is a little slow. But we need to pick up the pace because we've got quite a bit of work to do in this 2 hours. Right, you've got this. And you've got that. Remember, shift sine a half. How do we solve? Shift sine a half. You're going to check it on your calculator, 30 degrees. And your general solution is plus k times 360. Or quadrant number 2, 180 minus 30 plus k times 360. That's 150 degrees. Right. What music? What music is in the background, guys? They're saying the music. What music is in the background? Just check. Is that sorted? Sincere apologies. Is that okay? Is that better? Super Marv. Super Marv. Super Mario. Here we go. Okay, there we go. Right, let's look at the next one. There we go, sorted. Thank you, thank you. Wasn't my side. You know, we blame Asanine. Right, let's go. Let's look at this one. 2 cos 2x minus sine 2x. Here's one in terms of your double angle. Minus 1 equals 0. Give the general solution. Give the general solution. Right, what we need to do here, guys, is we need to get rid of the cos 2x and we need to get rid of the sine 2x. We need to get it to a quadratic equation. This is what we need to get it to. That's our aim. Our aim is to get this to a quadratic and to get two general solutions. That's what we want to do. Now, many of you don't know which of the cos formulas to use, but this will give you a clue, the middle term. Because sine 2x can only be broken up as 2 sine x cos x. Right. So that means there's a sine and a cos in the problem. That means, yes, you are right. So this is equal to 2. Then the cos 2x that has a sine and a cos in it would be which one? Cos squared x minus sine squared x. Yes or no? Minus 1 equals 0. So 2 cos squared x, if I remove the brackets, minus 2 sine squared x, minus 2 sine x cos x, minus 1. Now I need to get rid of the 1. Now look here, that's a square. That's a square. Here the power is 1, here the power is 1. That means I need to get rid of the 1. So what do? I just attach sine squared x plus cos squared x at the back of the whole number. Why? Sine squared x plus cos squared x from grade 11 is how much? It's 1. 1 times 1 is 1. I'm not changing this, but I'm introducing sine squared and cos squared to make it a perfect quadratic. Are you guys following? Now let's remove the brackets. 2 cos squared x minus 2 sine squared x minus 2 sine x cos x minus sine squared x minus cos squared x is equal to 0. Now let's collect our like terms. 2 cos squared x minus 1 cos squared x is just 1 cos squared x, right? Your middle term will be minus 2 sine x cos x. Minus 2 sine squared x minus 1 sine squared x is minus 3 sine squared x is equal to 0. There we go. At this point, we know we are right because it's a perfect quadratic equation. Onliners, I hope you are following. Onliners, I hope you are following. Please learn. Okay, let's go. Let's break that up. So that's going to be cos x times cos x. That's going to be sine x, and that's going to be sine x, to give me sine squared. This one is going to be 3. That one's going to be 1. That's going to be negative. That's going to be positive. So now I got two factors. So cos x minus 3 sine x equals 0, or cos x plus sine x equals 0. Now we need to give two general solutions. So take the cos on the other side. So minus 3 sine x is equal to minus cos x. Negative divided by negative is a positive. Divide by cos, divide by cos. Divide by 3, divide by 3. So you're going to be left with sine x over cos x. If I divided this side by cos, cos divided by cos is 1. And then divide by 3, divide by 3. And here the same thing, sine x will equal to minus cos x. Divide by cos, divide by cos, I'm going to be left with sine x over cos x is equal to minus 1. What is sine over cos? Good. So let's just do it here. I don't have enough space, but you'll have to continue down. So you're going to say tan x is equal to a third. Sine over cos is tan. X is equal to shift tan a third. Shift tan a third. 18,43 plus k times 180, where k is an element of integers. For 10, your general solution is k times 180. Or on this side, you're going to have 10x is equal to minus 1. X will equal to shift 10 minus 1 is minus 45 degrees plus 180k, or k times 180, where k is an element of integers. And there we go. There's your two general solutions. You'll get 6 to 7 marks for this. You'll get 6 to 7 marks for this. I'm going to show you one more style. So this is style 2. The first one was style 1, where you had to get it into a straight line, because the one was in terms of tan. You made it sine over cos, multiplied it. You needed to get it into a quadratic equation. That was style 1. Style 2, you had compound and double angles in it. You had compound and you got double angles in it. So we had to make it a quadratic. This is style 2. You have to know style number 3, which I'm about to show you now. Okay. This is the same. Okay, so the teacher asked, I think VB is a teacher. I'm sure you're a teacher, VB. So VB says, can we use variables to show you how this is a quadratic? Yes, we can. Because cos squared is the same as writing a squared. Minus 2 sine x cos x is the same as writing minus 2ab. Minus 3 sine squared is the same as writing minus 3b squared is equal to 0. So this quadratic and that is exactly the same. A squared, you know, in algebra, a squared minus 2ab minus 3b squared, your quadratic equation, it's the same. Cos squared x minus 2 sine x cos x minus 3 sine squared x. We're just calling cos squared a and sine squared b. Or cos A and sine B. That's all we're calling it. And then you factorize it. Agreed? Okay. Babongile, did you see that? Did you see that? Cos squared is A squared minus 2AB minus 3B squared. It's the same thing. Okay, I'm clearing here. Here's the last style. Very popular, you need to know it. If they tell you, give the general solution, here's the last one. Give the general solution. And they tell you that sine x minus 30 degrees is equal to cos 2x for 6 marks. Thank you, Babangile. Give the general solution here. Now, please, I beg you. This can be two graphs. They can say find the points of intersection of the two graphs. This one could be f of x, and that one could be g of x, and find the points of intersection. Show algebraically. So that means do not draw a graph. That means use general solution to find out the points of intersection of these two graphs. Or basically just give the general, in this case, just give the general solution. Now, I know it's very tempting. Pay attention. I know it's very tempting at this point to break this up into a compound angle and to break that up into a double angle. You don't do that. Who knows what to do here? You change the cos to sine. What do you do in a situation like this? You change the cos to sine. So we're now going to have sine x minus 30 is equal to sine 90 minus 2x. Because sine 90 will change it, so you're just rewriting it. You are not changing it in any way, but you are converting the cos to sine. Now, why do we do that? Let me show you. Pay attention. The minute you convert, so step number 1, you change the cos to sine. Step number 2, you cancel the two signs. Step number 3, you split it up into your two solutions, into quadrant 1 and into quadrant 2. So quadrant 1 is 0 degrees plus. Quadrant 2 is 180 degrees minus. So let's go. Let's do this. Right, pay attention here. So we cancel the two signs. Don't change it to cos. Don't change the sine to cos. Change the cos to sine. Just follow one system. I'm not saying it's wrong. I'm just saying it works out much easier. Right. So x minus 30 is equal to 0 plus. So I can just say 90 minus 2x plus k times 360, where k is an element of integers. Or my second solution, x minus 30 is equal to 180 degrees minus 90 minus 2x plus k times 360, where k is an element of integers. Let's now solve for x in each. So take this down. Take this down. Where am I getting the echo? Somewhere. Okay. Don't change it to cos, because you're going to change it to cos, you're going to get plus minus. It just makes it a little more trickier. Just stick to changing the cos to sine, not the sine to cos. Okay. So let's go. X plus 2x is 3x. 90 plus 30 is 120 plus k times 360, where k is an element of integers. So x will equal to 120 divided by 3 is 40 degrees plus k times 360 divided by 3 is 120, where k is an element of integers. Or, that's your first solution. Your second solution, let's solve for x. Let's remove the brackets on this side. 180 minus 90 plus 2x plus k times 360. So x minus 2x is minus 1x. 180 minus 90 is 90. Plus 30 is 120. Plus k times 360, where k is an element of integers. So x will equal to divide by negative, divide by negative, divide by negative, minus k times 360, where k is an element of integers. So you'll get 3 marks on the top, 3 marks at the bottom. There's your total marks of 6. Learn. Now all you do, if these were two graphs, if these were two graphs, then you can now, what if they gave you a restriction from minus 360 to plus 360? That now only do you start subbing in all your integers, 0, 1, 2, minus 1, minus 2 on the first one, and 0, 1, 2, minus 1, minus 2 on the second one. Whichever ones fall within your restriction, those will be the points of intersection of where these two graphs will intersect. Yeah. Yeah, but it gets a little rougher. Just don't do it. I don't have the time to explain it to you now, but just change the cos to sine. You can go home and play around with it and work it out. You'll see exactly why I told it to you. You'll figure it out for yourself. Right. How did we get here? Yeah, ne. You're asking after 12 years, how did you get to grade 12? Pure math at this point. It's rough. Let's go. So we're done with this. We're done with general solution. Learn the 3 types here. You can, if you wanted to put your plus k times 360, because remember your integers are going to be 0, 1, 2, minus 1, minus 2 in any case. So I'm just giving it to you in the format in which the memo gives you the answer. So the memo normally gives it to you as a negative, but if you put a positive here, it wouldn't have made a difference, because when you're going to be subbing positive and negative integers in. Okay, I'm clearing here. Okay, here we go, here we go, here we go. So let's go into the 2D trigs. Right, so let's give you a diagram. Watch this. Okay, take this diagram down, guys. Take this diagram down. We'll do about 3 examples here, guys. If you can do these 3 examples, you can do. Now, I've got a stack here. You know your files, what they look like. If you're looking at all 9 provinces and you're looking at the past 5-year papers, basically you're looking at 9 times 5 is 45 past papers. That's only end of the year. What about their June exam? What about their prelim exam? What about their supplementary exam? So you're looking at the close to about 180 past papers. Now it's going to be impossible for you or me to work through all 180. Well, if you got the time, go and do it. However, what you want to do is learn the art of doing it, so that you don't need to do 180 papers. If you can do 4 or 5 past papers, or maybe 10 at max, and master the art of attack, no matter what is going to come to you in the exam, you'll be able to manipulate it. So I'm going to do 3 examples for you now. Obviously, I can't do 180 examples in the little time that we have. So let's just utilize the time that we have to show you how to attack a question like this. So we've got that. Take this diagram down. That's P, Q, R, S. That's X, that's alpha, that's beta. Let's say that is parallel to that. This is angle theta. Right. Show that PS is equal to X sine alpha over sine alpha plus beta cos theta. Right, we're going to do 3 examples. The other one I'm going to give you another one, and then the last one I'm going to give you is from September 2023, last year's prelim paper. And I'll show you that the same style that we used to answer this, we'll be able to answer the one from the prelim last year. Right. Basic rules to remember. Here are your rules to remember, guys. This is the rules of this game. Number 1, you want to rename the common side. You want to rename the common side between the 2 triangles. You want to rename the common side between the 2 triangles. Number 2, if it's a 90-degree triangle you're working in, you always use SOHCAHTOA. And if it's a non-90-degree triangle that you are working in, we're either going to be using the sine rule or the cos rule. That's it. Okay? So let's rename the common side. Which is the common side here? QS. Now, let's look for clues. Right, in our answer. I'll show you how easy this is. Look in your question. You've got sine, sine. So already it's telling me use the sine rule. So I want to bring all my alphabets from triangle number 2, and I want to bring it. This is triangle 1, triangle 2. Triangle 2 is non-90 degrees. So I'm going to use the sine rule. Triangle number 2, I'm going to be using the sine rule. So I'm going to say QS over sine alpha, a side over sine of its opposite side, is equal to X over this angle here. Do I have that angle? Yes, I do. That angle, according to sum of angles of a triangle, is 180 minus alpha plus beta. Yes or no? So here goes. Over sine of its opposite angle, 180 minus alpha plus beta. Right, let's reduce this. Therefore, QS over sine alpha is equal to X over, you can reduce sine 180, it falls away because we're reducing. And then I'm only left with alpha plus beta. I want QS on its own. So times sine alpha, excuse me. So QS is equal to X sine alpha, multiplied on both sides, over sine alpha plus beta. Now, at this point in time, we don't think we're right. We know we're right. All I have to do now is get a cos in it, and that I'm going to get from triangle number 1. Now, in triangle number 1, it's a 90-degree triangle, so I'm going to use SOHCAHTOA. Guys, you can answer it in your exam exactly the way, look, you can answer it the way you want to, but if you're looking for a template or a way to do it, you can answer it exactly. I'm not doing rough calculations here. I'm doing it exactly the way you should answer it in your paper. Right. Let's go into triangle number 1. If that is angle theta and these two lines are parallel, that means that must be angle theta. We always work with theta inside, never with theta outside. That is your angle of depression. Right? Like what many of you are going through right now. Math is depressing you. Right, so let's go. Now, that's your opposite, that's your hypotenuse, that's your adjacent. You need PS, so you need this side and you need the common side. Adjacent and hypotenuse is cos. So in triangle number 1, I'm just going to move over here to the side. Cos theta is equal to adjacent QS over hypotenuse PS. There we go. So we use sine rule in the one. There's 2 triangles, so 2 rules. Triangle 2, non-90 degrees, sine rule. Triangle 1, 90 degrees, SOHCAHTOA. It's as simple as that. So now I want PS on the top. So I can flip this side, I flip the other side. PS over QS. I flip this side, I flip that side. 1 over cos theta. So PS on its own. Times QS on this side, times QS on that side is QS over cos theta. But therefore, here comes your final answer. Therefore, PS is equal to, instead of QS, I can put what I just found. X sine alpha over sine alpha plus beta. Cos theta is in the denominator, so you leave it in the denominator. And there we go, you'll get 5 to 6 marks for that. As simple as that. We're going to do another one now in terms of the cos rule. This one was in terms of the sine rule. I'm just trying to think what that one looks like. Oh my God. Oh, completely simplified, but I want to include a compound and double angle in it. Yes, I have to. Okay, take this one down. Okay, you got this one. Let's go. Right, watch this one. The next one's also a popular one. And then I'm going to give you the one from the prelim to do on your own. And that's going to be like a hot knife through butter. Right, watch this. Watch this. Okay, so the diagram looks like that, like that, like that, like this. Almost the same like the previous one. There. That is beta. That is H. That side is equal to that side. This is X. That's an isosceles triangle. This is angle alpha. Let me think what. So let's name it anything. Whatever you want to name it. Let's name it what? DEF, PQR? I don't care. Right. Let's name it triangle PQRS. Show that H the height, not H the hypotenuse, is equal to, I hope this works. I got a good feeling. X tan beta cos alpha. 6 marks. It could be 6 to 8 marks. Now, in this case, okay, don't write this for now. I just hope that it works because there's heavy logistics, there's some mechanics, there's some heavy nuts and bolts that need to take place in this question. Don't put this for now. But anyway, I think we're going to get to it. Inshallah. Right, so let's go. In this case, listen, in this case, we don't know whether to use a sine rule or cos rule because nothing in there gives me a clue. Because tan, that's not going to help me, but I got a cos alpha there. So if I got a cos, I'm going to try using the cos rule. I got a cos here. So let's use the cos rule. Right, let's all do it together. Before you write this down, the diagram is right. This here is 99.9% correct. Let's check. Right, in our answer. So, if this is angle alpha, this is an isosceles, that is angle alpha. If that is x, that is x. This angle is 180 minus 2 alpha. Right, so QS, to rename the common side, QS squared. So let's do it together. Right, don't write, let's all do it together. QS squared is equal to the sum of the remaining side squared, x squared plus x squared, minus 2 times the product of the two sides, x times x, times cos of your 180 minus 2 alpha. Right, let's go. QS squared, this is the cos rule. X squared plus x squared is 2x squared minus 2x squared. Cos 180 will remain cos 2 alpha. 180 minus is in my second quadrant. Cos is negative. Negative times a negative is a positive. So be careful. QS squared is equal to, I got two terms. What's my highest common factor? 2x squared. What's left over? 1 plus cos 2 alpha. Now, let me get rid of this. Okay, QS squared is equal to 2x squared into 1 plus cos 2 alpha. Which of your cos 2 alpha got a minus 1 in it? So a minus 1 and a plus 1 can cancel each other out. Isn't it 2 cos squared alpha minus 1? Yes or no? Right. So plus 1 minus 1 cancels out. So QS squared is equal to, it's only that times that. 2 times 2 is 4x squared cos squared alpha. So QS is equal to the square root of 4x squared cos squared alpha. QS is equal to, the square root of 4 is 2. The square root of x squared is x. The square root of cos squared is cos alpha. Okay, so it's 2x cos alpha. I think so it's 2x tan beta. I think that's where I went a bit out. But in any case, this is correct. This is 100% correct. So now we got QS. That's angle beta, guys. That's angle beta. So this is angle beta. I need QS and I need PQ. So I need opposite over adjacent. I need opposite over adjacent. So I need tan. So in this one, it's going to be tan beta is equal to H over QS. I want H on its own. So H times QS, QS tan beta. Now we just take QS and we plug it in there. Here's your final answer coming up. H equals QS is 2x. There we go. There we go. Tan beta, cos alpha, cos alpha. And there we go. It includes your double angle of cos in it. Okay, now you can take it down. The only thing I left out in the question was a 2. 2x tan beta cos theta. There we go. There we go. Take it down, guys. Take it down. And now you'll see the one that came out in your past paper. You'll be able to fly through it. I swear all of you are going to look at it. You're going to smile at it. And you're going to pray that they give you something like this in your exam. In fact, the next one from your prelim paper is easier than the 2 that we've done. Huh? No, yeah, the one that came out in 2023 prelim paper. Watch. Right, so if you want to take the next one down, okay, so those of you who took this diagram down, I'm sure you all did that already. So here's the one from the 2023 prelim. Gauteng. I think this is Gauteng. No, KwaZulu-Natal. Right, so KZN 2023 prelim paper. Here's the question. So they give you a diagram like this. Take it down, guys. And they give you a triangle coming down here and there. They call that Q. There. That's P. That's angle theta. This is R. That's alpha. That's 8 minus 2x. This is angle beta. This is S. That is X. Right. There we go. There's your diagram, guys. There's your diagram. Take it down. Show that PQ. Here's it. 5 marks. Right. Here goes. Show that PQ is equal to X sine beta over sine alpha tan theta. Done. Come on, look at it and smile. I hope you're smiling looking at it. You already know where this problem is going to. Rename the comment side. Rename the comment side and get your answer. It's as simple as that. It's as straightforward as that. Which is your common side, guys, that you're going to first rename? Ah, you're so clever. You're all getting 100%. And already looking at this and looking at the templates that I gave you, tell me which rule are we going to use? Sine rule or cos rule? Sine rule. Thank you very much. Right. A problem like this now in your exam should take you under 30 seconds to do. A problem like this should take you under 30 seconds to do. We firstly renaming the common side QR. Right, so that was your first question. The second question, if beta equals 60, show that the area of triangle QSR is given by 2 root 3x minus root 3 over 2x squared. Question number 3. Find the value of x for which the area will be a maximum. Again, they're talking about maximum. A little bit of calculus here in tricks. Find the value of x. Find x for maximum area. 533. Mark allocation. 5 marks. 3 marks. 3 marks. 8, 11 marks, guys. 11 marks on this. And then that would bring us to the end of 2D or 3D trigs. We got an hour to go. I just want to show you guys what to use, the tools to use in circle analytics, and then we'll end up with Euclidean. Hopefully, if we have enough time, we'll do probability. Okay, so let's do this. Okay, so rename the common side. QR over sine beta equals, okay, so what do we have? We got beta. So x over, yes, QR over sine beta is equal to x over sine alpha is equal to x over sine alpha. So QR on its own is equal to x sine beta over sine alpha. X sine beta over sine alpha. We go back into this triangle, opposite, hypotenuse, adjacent. I need PQ. So that's opposite over adjacent is tan. So now I'm going to say, therefore, in triangle number 1, tan theta is equal to PQ over QR. But I need PQ on its own. Therefore, PQ on its own is equal to QR tan theta, QR tan theta. So PQ, QR x sine beta over sine alpha tan theta. Boom, you got yourself your first 5 marks. Was that difficult, guys? Not at all. If angle beta is equal to 60 degrees, show that the area of triangle QSR. So now they're testing you your area formula. Right. So area is equal to half of a side times another side times sine of the included angle. They're telling you beta is equal to 60 degrees. So there we go. That's your area. Now they saying, show that your area is equal to that. So area is equal to a half x into 8 minus 2x. What is sine 60? It's your special angle. Root 3 over 2. So area will equal to root 3 times 1 is root 3 over 2 times 2 is 4x into 8 minus 2x. Now we can simplify that. We can simplify that. So, which is equal to root 3x. So 4 goes into 4 once, 4 goes into 8 2 times. So it's 2 root 3x minus 2 goes into 2 once, 2 goes into 4 2 times at the bottom. So you're going to get root 3 over 2. X times x is x squared. Bada bing, bada boom. Done. There's your final answer. Now, find the value of x for which area is a maximum. What did I teach you yesterday when we did calculus? Whenever we use the word minimum or maximum in mathematics, anywhere, derivative. Right. So now, differentiate. You got area. I'm just going to erase this. We're answering question number 3. We're finding x for maximum area. We're finding x for maximum area. Let's answer question number 3. So area is equal to 2 root 3x minus root 3 over 2x squared. Therefore, dA over dx is 2 root 3 minus 2 times this, 2 and 2 will cancel, it's root 3x. For minimum or maximum, what do we know about derivative? Is equal to, so minus root 3x is equal to minus 2 root 3, negative, negative, root 3, root 3. What is x equal to? X is equal to 2 for maximum area. And this was the prelim KZN component of this. Not difficult at all. Not difficult at all. Okay. What do you guys want to do now? How many of you are battling with factorials and fundamental counting principle? Factorials and fundamental counting principle. So then, okay, if I do that, then we won't touch on, because I'm looking at time, we still need to do Euclidean and analytics. Come on, analytics is easy. No. It's so easy. Time, how? Huh? Probability or circles? Circle analytics. Right, here we go. All right. Let's start off with the probability. Let's start off with the probability, and then obviously we have to do some Euclidean. Right, watch. Now, I'm going to give you templates in probability. Pay attention. The first thing you get in probability, you get fundamental counting principle and you get factorials. Right, pay attention. Fundamental counting principle, your number of spaces is not equal to your number of options of possibilities. I'll explain to you what this means. Factorials, your number of spaces that you have is equal to your number of possibilities. That's the major difference between the two. Factorials is represented with an exclamation mark and it gets multiplied. This one gets multiplied all the way down to the number 1. This one not multiplied all the way to the number 1. Right, let me give you an example of fundamental counting principle. Example. You have a 4-digit code. You got a 4-digit code and you can use the numbers 0 to 9. Right. They tell you how many combinations can you have if the numbers can be repeated, so with repetition, or without repetition. How many combinations can you have if you're using the numbers 0 to 9? Right. So with repetition, from 0, you can use 0 to 9. That means you got 10 numbers to use. Now, can you see you got 10 numbers to use, 10 possibilities, 10 options. But it's not equal, 10 possibilities is not equal to your number of spaces, which is 4 spaces. So therefore, it's not a factorial. What is it? What is it? Fundamental counting principle. So now you just say 10 times 10 times 10 times 10, which is equal to 10 to the power 4, which is equal to 10,000. You got 10,000 possibilities. And what is the probability of you getting it right? The probability of the event of getting the right combination is 1 out of 10,000. Are you guys with me? Your number of possibilities is not equal to your number of spaces. It's fundamental counting principle. We are not multiplying it all the way down to the number 1 like factorial. It's just 10 times 10 times 10 times 10. Without repetition, 1, 2, 3, 4, I'll have 10 numbers to use. That's with repetition. Without repetition, I used 1 number out of 10, I got 9 numbers to use. I used 2 numbers, I got 8. I used 3 numbers, I got 7. So it's 10 times 9 times 8 times 7. It's still fundamental counting principle. It's not a factorial. We are not multiplying it all the way down to the number 1. 10 times 9 times 8 times 7. I get 5,040. There are 5,040 different combinations. There we go. Another example of fundamental counting principle. All right, you're living in... Okay, so if you were living in Gauteng and you have your number plates, you know your number plates? Right. Gauteng number plates have got 2 letters, 2 numbers, 2 letters, and GP. Right. So you got letter, letter, number, number, letter, letter. They tell you no vowels with repetition. How many possible number plates are there? How many different combinations can be done with no vowels with repetition? So how many vowels do we have? 5. A, E, I, O, U. So that means letters in the alphabet, I got 26. Now 26 minus 5 is 21. With repetition, so I could have B and a B, or D and a D, a M and a M, a K and a K. So 21, 21. Numbers 0 to 9, including 0, is 10 numbers. Numbers here, 10 numbers. I can have a repetition here, 21, 21. All we do, we multiply them all out. Fundamental counting principle, 21 times 21 times 10 times 10 times 21 times 21. I get 19,100,000 448,100 different number plates in Gauteng alone. That means 20 million cars on the road if all the number plates were used, because each car has one unique number plate. Right, we done? Right. So that is another example of this. Is they give you a menu at a restaurant. You get 4 starters, 5 main course, 3 desserts. In how many different ways can it be done? It's again fundamental counting principle. It's not factorial. Now we're going to factorial, and there are about 5 different templates. There are 5 different templates which you just need to learn. And in fact, what I'll do, I'll take out one from a past paper again, from a national paper, and I'll show you how to play around with those factorials in that. Please also learn, I'm not going to do revision of grade 11 today, so make sure you learn your two-way contingency table to prove mutually exclusive and independent events. Make sure you learn your tree diagrams. Make sure you learn your tree diagrams. And make sure you learn your 3-value Venn diagrams. 3-value Venn diagrams. Tree diagrams. Two-way contingency table from grade 11. And now, obviously, your factorials, 100%, you're going to be tested on either fundamental counting principle. I think you'll get 1 on fundamental counting principle. You might get 2 under factorial. Right. Now watch here. Here's type 1. In how many ways can 6 different cans of cool drink or cold drink be arranged in a straight line in a fridge? Be arranged in a straight line in a fridge. So your answer is, you got 6 different cans. Please, they are not the same. The important word that you, okay, what's the important information? In how many ways? 6 different cans be arranged in a straight line. So that's what you need to underline in your exam. So that means in a straight line, 1, 2, 3, 4, 5, 6. They're all different. In the first space, watch here. Can you see your number of options is equal to your number of spaces? Your number of options is equal to your number of spaces. So it is factorial. It's not fundamental counting principle. Now pay attention. In the first one, you got 6 cans to choose from. You use 1 can in the first place. So how many cans have you got to choose to fill in your second space? 5. We use 2, 4, 3, 2, 1. All we do is 6 factorial. And 6 factorial on your calculator, 6 shift X exclamation, boom. How many ways? 720 ways. Yes. Yeah, we're getting there. We're getting there. This is just level 1. We're going to level 5. Don't worry. Relax. We're getting there exactly to what you answered. I won't leave it out. I promise you. Right. The second one. Pay attention. So this was type number 1. Type number 2. In how many ways can 3 out of 7 cans be arranged? Right, now pay attention here. So what you do is you take your total factorial divided by your total minus your target factorial. Right? This is my own way of trying to explain it to you. But you can learn this. It's our formula. It's our way of understanding it so that you always get it right. So what's your total factorial? 7 factorial. Divided by, your total is 7 minus, your target is what? 3 factorial, which is equal to 7 factorial over 4 factorial. Here's your final answer. 7 factorial over 4 factorial. 210 ways. Right. This is style number 2. Now you ask me the question, what if 2 of them are the same or 3 of them are the same? That's grouping. So let's do a grouping example now. You guys following? I know you're tired. I know your brains are fried. It's Sunday afternoon. Let's go. Onliners, I hope you're taking this one down. Right. I'm clearing the frame. Right. So a student has 5 math and 4 science books. If 3 math books need to be placed next to each other, next to each other, in how many ways can the books be arranged? In how many ways can the books be arranged? Right? Now, these are all 4 different ones. We're going to get just now where they give you what the question that you asked for identical. What if 3 of them are identical? We're going to get to that. So this one is 5 different math, 4 different science. But they're just saying that 3 certain books, math books, need to be placed next to each other. Right, so in this case, we got 1, 2, 3, 4, 5 math, 1, 2, 3, 4 science. So we got math, 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 science, 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 science. Right. 3 math books need to be next to each other, so you can group any 3. Now pay attention. Right. Now you take your remaining spaces factorial multiplied by the number in this group factorial. So let's look at remaining spaces. So tick it off, 1. This whole 3 books, we regard it as 1 space because they're going to all move together. So 1, 2, 3, 4, 5, 6, 7. So remaining spaces is 7 factorial multiplied by the number in the group, because this math can be there, this math book can be here, this math book can be there. You can spin these 3 math books within the group also. So that's why we multiplied by 3 factorial. So now, there we go. Remaining spaces times number in the group. So now what do we have? We have 7 factorial multiplied by the number in the group, 3 factorial, and that gives me 30,240 ways. Make sense? Right. Last type. Last type. And that brings us to the end of factorial and fundamental counting principle. Now, the same thing would be if a group of boys and girls are going to the movies. What's the probability that two boys will be sitting next to each other, or a girl and a girl at the end? It's the same as what we are doing now. If three boys, here's the same one, if three boys had to be sitting next to each other. So, 5 boys and 4 girls go to the movies. If 3 boys need to be placed next to each other, in how many ways can everybody be seated? It's the same example. Right. Now have a look at this one. Here's the last one, right? So, consider the word, let's use the word, the one that we always use, Namakwaland. Right. In how many ways can the above word be arranged? Now, this answers your question. What if they are identical? Because now you said, what if two things are the same? So here you go. You got this. You got identical letters. Yes or no? Right. So watch this. Yeah. So in how many ways can the word be arranged? So what you do in this case here, whenever you have, now we're not talking about numbers in a group. We're not talking about grouping. Grouping was the other model that we did, where you had to group 3 books. We're not doing that anymore. Now we're doing what identical. We are dealing now with identical letters or identical items. Right. You take your total factorial divided by however many are repeated. Repetition times repetition times repetition. Or repeating. So your total factorial is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. Divided by, why divided? Because we're eliminating the repetition. So how many A's have you got? 1, 2, 3, 4 A's. What else is repeated? 2 N's. Multiplied by 2 N's. You got 4 A's, 2 N's. Your total factorial, 4 A's, 2 N's. Do this on your calculator. 11 factorial divided by 4 factorial multiplied by 2 factorial. That gives you 831,600. Right, now pay attention. In how many ways can the above word be written if it started and ended with an N? Again, this is the same thing like boys and girls go to the movies. What is the probability that on the first seat and the last seat you're going to have 2 boys or 2 girls? Right. So watch what happens here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You must do this in the exam. So the first one, it must start and end with an N. So how many factorial do we have left? How many letters do I have left? 9 factorial. Divided by, I still got 2 A's and I still got 2 N's. Because I took out 2 N's. The other 2 N's are fixed. Right? No, I took out the N's. So it's only 4 A's. It's only 4 A's. I took out, because we had 4 A's and 2 N's. The 2 N's are gone. First and last. So I'm only left with the 4 factorial. So now 9 factorial over 4 factorial. 15,120 ways. No, but here it's identical. So whether it's a n here and unless they were different, then you'll multiply it by 2. Yeah. Or sometimes you'll find that they talk about married couples, like maybe 4 married couples are sitting in a row. Now, obviously, in the married couple, it could be husband and wife or wife and husband. Then you'll multiply it by 2. But this is identical. Right. Calculate the probability that a word chosen will start and end with a N. Calculate the probability that a word chosen will start and end with an N. Now we're finishing off at 3, guys. We are finishing off at 3 because I know everybody's made arrangements. Right. So obviously, your answer for this one here, the probability of the event, of it starting and ending with an N, will be 15,120 divided by 831,600. And that will equal to 1 out of 55. There we go, the probability of an event. So, guys, I've broken up this question for you in 3 parts. They can ask you 1 6-mark or 8-mark question. Consider the word namakwal and calculate the probability that a word chosen will start and end with an N. You still have to do it in the same way. You break it up. I've just broken it up for you in bite-sized pieces, in steps. It can be a 6 to 8-mark question. If they just asked you the last one on its own, you still have to follow the procedure. Make sense? Good. All right, let's go. Right. Let's do Euclidean. Are you guys ready for Euclidean? You want to take a 5-minute breather? Bathroom break. Fresh air. Take 5 minutes. I'll see you guys in 5 minutes. We're sitting already from 1 to 1.5 hours. All right. 5 minutes only, guys. 5 minutes only. We come back and we're ending up with Euclidean. Take a 5-minute break. We'll go a couple of minutes over, it's fine. Few minutes. Right. Taking a diagram here, take the circle down. Take the circle down. O is the center of the circle. They give you a line going right across. Take this one down. They give you a line till there. Give you a line coming down here. They give you a line coming down there. They call that Y. They call that X. O is the center of the circle. This is T. This is R. That's point P. And that's point S. They say show that Y equals 270 minus 2X for 6 marks. Okay, let's see. Onliners, we're back. We have resumed. Nothing else given. Right. The minute you see a diagram like this, guys, the minute you see a diagram like this, what you want to do is you want to try and include the only thing that we can do here is we've got a diameter. We know a diameter subtends a 90 degrees at the circumference angle in a semicircle. Yes or no? Right. We also know that TS is a tangent. They tell us TS is a tangent. So we know that angle T is equal to angle R. Correct? So we can use angle in a semicircle. We can use tan chord. And which other theorem can we use? There's nothing else. There isn't a cyclic quadrilateral. The only other thing that we can use is sum of angles of a triangle. Or we can use exterior angle is equal to the sum of the interior opposite angles. Yes or no? Right. So let's see. Let's see. So we know in our answer, let's just fill out what we have. Angle T is equal to 90 degrees, and they'll give you 2 marks just for processing and for identifying this. T is equal to 90 degrees. Angle in a semicircle. Angle in a semicircle. Right. So angle X. So what is angle X equal to? Angle X is equal to angle R plus 90. Angle R plus 90 degrees. Exterior angle of triangle is equal to the sum of your interior opposite angles. Right? So what is angle R equal to? Angle R is equal to, therefore, that means we are concluding, making a conclusion from here. Angle R is 90 minus X. So there we go. R is now called 90 minus X. Now what did I say? We can also use tan chord. We have to use tan chord because that's a tangent. So therefore angle T, STP, but, or therefore, we can say therefore, angle STP is also equal to 90 minus X, tan chord theorem. So this angle here is also 90 minus X. Now let's see, we need to show that Y. Let's look at the big triangle. I'm now just looking at the big triangle. I'm looking at the big triangle. So therefore, this whole angle plus that whole angle plus Y is equal to 180. Yes or no? Sum of angles of a triangle. So now I'm going to say in triangle STR. In triangle STR, Y plus 90 minus X plus 90 plus 90 minus x is equal to 180, sum of angles of a triangle. Let's see if we can get y on its own. So 90 plus 90 plus 90 is 270. So y plus 270 minus x, no man, STP, yes, STP is also, it's 90 minus x, that's also correct. Oh, wait, sorry, this is x minus 90. It's not 90 minus x, it's x minus 90. Sorry about that. Let's go back. Because your exterior angle is equal to the sum of your interior. Right. So x is equal to r plus 90. So r is x minus 90, not 90 minus x. X minus 90. So STP is also x minus 90. Let's go back. X minus 90. So now let's go back. Let's just put it in here. Let's erase all of that. And let's fill in what we have. So this is x minus 90, and this is x minus 90. So let's go again. Y plus x minus 90 plus 90 plus x minus 90 is equal to 180. So y plus 1x is plus 2x. Plus 90 minus 90 is 0, is equal to 180. Minus 90 will come onto the other side as plus 90. Y plus 2x is equal to 270. There we go, 270. Therefore, y, here's your final answer coming up. Y equals 270 plus 2x will come onto the other side as minus 2x. There we go, and you'll get 6 marks for that. You'll get 6 marks for that. All right. Let's take another paper here. And let's go through some of their similarity and proportionality. Right. You might even get one with Pythagoras. You might get, so obviously, you know, you need to learn your proof of your angle at center. Exterior angle at center is equal to 2 times angle at circumference. That's from grade 11. You might need to learn your the proof of your tan chord theorem, or exterior angle. A very popular one, which is your other very popular one? If you've been working through past papers, which is your other very popular one? Line drawn from center of circle to midpoint of a chord is perpendicular to the chord. Yes or no? Or line drawn from center of a circle perpendicular to the chord bisects the chord. All right, so learn those proofs. Let's look now at, I'm looking at November 2021. Okay. Whoa. Okay. Right. Let's start off with one. This is probably also about. Okay, let's take this one down, guys. Take this one down with me. Here we go. So they give you from there to there, from here to here. M is the center. So you got a line going through the center till there. You got a line going across there. You've got a line coming right down here. And you've got a line coming across here. Okay, so this is C. That angle is X. This is A. A1, A2, A3. That's B. That's D. That's M. M1, M2, M3. That's F. That's 90 degrees. And that's E. Okay. In the diagram, B and CD are diameter, BE and CD. BE and CD are diameters. So the minute they tell you diameters, look for the 90 degrees that the diameter subtends. M is the center of the circle, so look for, you can also look for radii. AE is perpendicular, AE is perpendicular to CD. There we go. Right, question number 1. Why is AF equal to FE? Why is AF equal to FE? They just want the reason. So why is AF equal to FE? Why is AF equal to FE, guys? Because you got a 90 degree here, yes or no? And line drawn from a center of a circle perpendicular to the chord bisects the chord. So AF is equal to FE because line drawn from center of circle. From center of circle perpendicular to the chord bisects the chord. They give you 2 marks just for stating that. Number 2, find M1 in terms of X. Find M1 in terms of X. Come on, that's easy. Or is it? Find M1 in terms of X. They don't tell you these 2 lines are parallel. I'm just trying to see something here. Oh, M1. What is M1 related to? So whenever you're doing geometry, whenever you're doing Euclidean, you start with what they give you. So let's start with M1. M1 is related to which angle? Very good. M1 is equal to A1. Why? Angle at center is 2 times angle at circumference. Am I right? So what is A1 known as? A1, so let's go, let's write it out. Now, how do we process, how do we write out a logical explanation to it? So we're going to say angle A1 plus X plus angle C plus 90 degrees is equal to 180 degrees. Sum of angles of a triangle here. So angle A1 is equal to 180. So here, obviously, you have to write sum of angles of a triangle. And which triangle are you looking at? CFA. CFA. So A1 is 180 minus 90 minus X. So angle A1 is equal to 90 minus X. So A1 is 90 minus X. Angle at center is 2 times angle at circumference. These 2 are related. So therefore, angle M1 is equal to 2 into 90 minus X because angle at center is equal to 2 times angle at circumference. Now this is 4 marks. So M1 is equal to 2 times 90 is 180 minus 2x. So M1 is now 180 minus 2x. There we go. So you got 2 marks here, you got 4 marks here, you got 6 already. Prove that AD is a tangent to the circle passing through AC and F. A, where's C? A and F. Prove that what's a tangent? AD. Where's AD? Ah, good, yeah. Hmm. AC is parallel. No. B? To AD. So then how would it make these two lines even? Okay, so this is line drawn from center of circle. Where's the whiteboard? Khalid? Okay. Sorry, I just want to respond to Aiden. Aiden, what line drawn from center of circle, but this is not to a midpoint of a chord. This is not 90 degrees. Okay. Moving along. Yeah, so those two lines, unless they told you that these two parts are equal, then it would be 90 degrees. Right, let's go to the next one. It says that prove that AD is a tangent. Right, so here goes. For 4 marks, question number 3, prove that AD is a tangent passing the circle CFA or A, C, and F. Let's go. Let's do this. Right. Now, when you see a question like this, they prove that something is a tangent passing through a circle. Right. So, circle A, C, and F. So, what you do is you draw a circle here around ACF. A, C, and F. It doesn't need to be a perfect circle, but you must just, because they're telling you there's a circle passing. Now, the only way that AD can be a tangent is if you prove that angle A2, remember, they want you to prove that AD is a tangent. Pay attention. They want you to prove that AD is a tangent. So the only way you can prove, so I'm just going to draw the circle here thicker so you can see it. The only way that you can prove that this is a tangent to that circle is if you prove tan-chord theorem. If you prove that angle A2 is equal to angle C, because there's your triangle. There's your triangle. You need to prove that A2 is equal to X. If we can prove A2 is equal to X, therefore AD is a tangent. Why? Tan-chord theorem. The converse of the tan-chord theorem. What does the tan-chord theorem state? Angle between tangent and chord is equal to the angle in the alternate segment. The converse states that if an angle between a line and a side of a triangle is equal to the angle in the opposite angle, therefore that line is a tangent to the circle drawn around it. So now we need to prove that A2 is equal to X. How do we prove that angle A2 equals X? We know that one is X. It's a diameter. Very easy. No, let's do it this way. Remember I said that we spoke about the diameter. So a diameter subtends a 90 degrees angle in a semicircle. Right. So that means this whole angle here is 90 degrees. Right. So let's go. Let's write it out. Now, how do we write it out? We say angle A1 plus angle A2 is equal to 90 degrees. Angle in a semicircle. Angle in a semicircle. But angle A1 is equal to 90 minus x, proven above. Therefore, instead of A1, what can I put? 90 minus x plus A2 equals 90. I want A2. Angle A2 is equal to 90 minus 90 plus x. A2 equals 90 minus 90 is 0. What am I left with? A2 is equal to x. But angle C is equal to x. Given. Therefore, A2 equals angle C, which is equal to x. Therefore, AD is a tangent. AD is a tangent. That's what we just proved now. AD is a tangent to the circle ACF. And the reason for that, you must give, I don't have space here, I'm just writing the reason here, the converse of your tan chord theorem. There we go. Okay. One more question here for 5 marks. We got 2 minutes left. It's 3 o'clock, 2:58. Given that CF equal, right, so let's do the last one. 5 marks. 5 marks. Thank you, Tumelo. Now here's your 5-mark question. I'd love to sit here till 4 o'clock or 5 o'clock and do so much more with you. Unfortunately, we don't have time and you guys have made arrangements. Right, given that CF is equal to 6 units, AB equals 24 units. Take this one down, it's a 5-mark question. Calculate with reasons the length of AE. Find the length of AE. Find AE for 5 marks. Okay, here goes the stress. Let's start the stress. Okay, in our answer, let's see, what do we have? They say CF. Where is CF? Where's CF? Oh, yeah, that's F. That's F. So CF is 6 units. So put a 6 there. AB is 24. AB is 24. Find the length of AE. Find the length of AE. So we need to find, I'm just going to highlight that in a different color. Find AE. That's what we need to find. Give it a go. Something tells me we're going to have to use similarity. Something tells me we're going to have to use similarity. They only give you those two. They give you AB is 24. Your brains are burning now, brah. Brains are burning. Come, guys. Apply. Let's go. So we got this as 24. We got that as 6. What can we use here? What can we use? So we proved earlier on that AF is equal to FE. Okay, good. Okay. Come guys, apply your brains, apply your mind. Think proportionality. Think proportionality. We got this side equal to that side. So if I had to split this triangle up, watch what it would look like. It would look like that. And then we got a line going here. Because we got that piece equal to that piece, AFE, AFE. And that is also the center of the circle. Haha. So these two are radii. So that is equal to that. Now, don't you remember? So that means this side is equal to that side. So that means that will make that parallel to that. And thus, half of that in length. Remember your midpoint theorem from grade 10? Midpoint theorem. A line from the midpoint of one side to the midpoint of the other side makes it parallel to the third side and half the third side in length. So if this is 24, FM is 12. That's M. So it's parallel and it's 12. It's half of 24. Okay, so let's go. Let's write it out. Let's write it out. AF equals FE, proven. Right? AF, because we proven it, line drawn from center of circle. But we proved it above. Right. MB is equal to ME radii. Therefore, FM is parallel to AB and half of AB in length. That's your midpoint theorem from grade 10. Therefore, FM is equal to 12. FM is equal to 12. Right. That's 90 degrees also. EM equals MB. EM equals MB equals CM. Right, wait, give me a second. Is equal to CM. Right. So let's go. So we got this piece here as 12. We got that piece as 6. That means this whole radius here is 18. Therefore, CM is 6 plus 12, which is equal to 18, which is equal to MB, which is equal to ME, because they are all radii. So this is 18, that is 18. So obviously now we got this as 12. We got this line here as, now we're looking at this triangle. Watch here, guys, watch here. Here's the answer coming up. We got that piece as 6. We just calculated this piece as 12. 6 plus 12 is how much? 18. That means that length is also 18. That's a radius. That length is always also 18 because that's also a radius. Pay attention. So we got 12, we got 18. Now I can find FE in this triangle. So now let's go into that triangle. Let's do Pythagoras. We're almost done. Right. In triangle FEM or EFM. Right. 18 squared, ME squared is equal to FE squared plus that squared. What's that? FM squared. Pythag. So 18 squared is equal to FE squared, which we're looking for, plus FM squared, 12 squared. Here we go. We're almost there. So FE squared is equal to FE squared is equal to 18 squared. Let's just go. Where's my calculator? Disappeared. There we go. Right, 18 squared. 18 squared minus 144, 180. So FE is equal to the square root of 180, which is equal to 6 root 5. Very good. So if this piece here is 6 root 5, and that piece there, these two are equal, they wanted the length of AE, therefore AE is equal to 2 times 6 root 5. Therefore, AE is equal to 2 times 6 root 5, which is equal to 12 root 5 units. There we go. And that brings us to the end of today. Boys and girls, thank you very much. Give yourselves a nice round of applause. I know it's at this point of the time where you have completely bombed out. I just want to say thank you all. You guys have been amazing over the past 2 days. Onliners, thank you so much. Yes, hectic bananas. AE 12 root 5, Blitzkrieg. Well done, well done, well done. Thank you so much. Lots of love from our side. Thank you to South Peninsula. Thank you to Awqaf. And thank you to all of you and all the schools and teachers who have put this program together. It was an amazing session.
How's a round of applause there?
Yeah,
Come on,
lovely.
everyone. This was a solid cohort, Mr. Kota.
Solid.
Respect to all of you guys online as well. You brought it. Here's to your success. Thank you so much.
And meet again at the end of the year. Remember, our program will be, please guys, stay tuned. Check your emails. We're planning the final one, the final workshop for grade 12 around early October. So stay tuned and love to see you guys all very soon.
So
Thank
there
you
we
so
go. That's where we conclude here at South Peninsula High School. Thank you for logging on. Please do log on to Awqaf's YouTube platform, Awqaf South Africa. If you've got any concerns, have a look at some of the past videos. Thank you so much for all the educators, learners. Thank you for your focus and your dedication. Khalid's been doing a fantastic job here, Mr. Kota.
Yes.
With the technical.
Absolutely.
We've hosted a few interviews with some of the participants. So yes, we'll see you next time.
In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and dignity.